Hey, what's up guys? Moving one step forward, this particular tutorial along with the architectural design is going to incorporate the structural considerations in much more depth and details, wherein I'm going to design different types of footings, namely isolated, combined, raft foundation and step footing with all the details and its joint condition with column, beam and floor. But before that, I would like to acknowledge and give credentials to a few people who have helped me pursue this particular project, wherein one is A&B, that is Architecture and Beyond, an architectural firm of Surat, where architect Ashish Patel and architect Bhavesh Patel are the principal architects, who is one of the executed projects we are going to design today in Revit. So this is that executed project by the firm with that interesting form, of which I have tried to model this particular load bearing wall, which is very interesting and the major highlights of this composite structure, wherein this thick load bearing wall is getting converted into roof. So we are going to design the same wall with all the structural considerations starting from footing. Also, I would like to thank structural engineer Narendra Kapadia and Nilang Gaiwala, who helped me regarding the structural concerns for this particular project so that I can explain you guys better regarding the structural considerations. So this is that typical G+3 low-rise residential apartment which will be delivered in two phases, wherein the first part I'll be talking about that masterpiece and that particular advanced form with all its details and joint conditions. Also, this particular tutorial is going to talk about the designing of different wall types with different thickness and its several different layers, that is acoustics, insulation, cavity, etc. So guys, it is going to be a very interesting tutorial. Watch the entire tutorial till the end. And welcome back to ptscadexpert and myself, architect Kumar Kapadia from the city of Surat in Gujarat. And now, without wasting a single second, let's jump into the interface of Revit. Welcome students for this course, Master Diploma in Revit BIM, which is a combo of Architecture plus Structure plus MEP. For the architectural segment, what all we have seen so far is all this 3D drafting commands under this Architecture tab, under the Build panel and the Circulation panel. But all of that in parts and pieces and in segregation. Moving to the next segment, that is, I'm always saying that Revit is not only about modeling the 3D interface, but it very efficiently and prominently does model the 2D interface, that is the essential building assets and the information that we feed on to a particular structure for its execution inside, that is under this Annotate tab. If I see this dimensions, the details, the text, that is the nomenclature, the tagging part, the colorful legends and symbols, the implementation of which I'm going to show you on an entire structure. So this is that floor plan of that particular structure which we are going to elevate today in Revit. And if I just acquaint you to this, then this is nothing but a G+3.5 residential apartment which we are going to execute today in Revit, wherein it has an elevated plinth of 3 foot, which has this office areas, this gazebo and gymnasium, and also the landscape part has been taken into consideration, wherein we have some swimming pool, garden, amphitheater, etc. And the typical floor plans of that includes the living spaces, which has the semi-private, private and the public spaces. And this is the amphitheater. There is the bridge which is leading to this particular amphitheater and the bedroom and so on. Also, not only the architectural modeling, but we will also be taking into consideration the structure part, which has been pursued with negotiations and discussions with a structural engineer in my neighborhood, and also a couple of students from this course has helped me to pursue this particular structure, wherein the consideration says that this particular entire portion will be excavated. This particular piece of land will be excavated from the site, wherein we will have a foundation going up to the depth of 10 foot, and then a raft of 600 mm, that is 2 foot, will be provided with the layer of PCC. Okay, and this particular entire structure, this columns and this shear walls will be resting on that particular plinth. And also, if you see that this peripheral walls will be the retaining walls, which will retain the lateral pressure of the soil. The exact cross section and size of that will be decided by the structural engineer, and I will be considering all the basic sizes as per the beam and column, and its sizes and its location. Everything will be pretty much conventional, basic. The exact solution of which will be given by the structural engineer, wherein I might be partially correct or I might be completely wrong, but the only motive is that I want to show you guys that how can you incorporate basic structure while working on an architectural model in Revit. Okay, and talking about this portion, then you can see that all the columns have the conventional footings, wherein this are the isolated footing, this is the combined footing, and this is the step footing. The reason of providing this particular thing as a combined footing is that in order to construct, when we excavate this particular portion of the site and this retaining wall, for the construction of this retaining wall, we need a minimum margin of 4 feet to 5 feet, that is 1.2 meter, to lay its shuttering and everything. So this much portion will also be excavated, and once the job is done, then again we will have the backfill in this particular portion. So this particular footing will be resting on the portion which have been filled artificially with artificial soil, so there are chances of settlements. So in order to achieve the strength, this particular thing has been conceived as an isolated as a combined footing, and thanks to Mr. Atif Aslam Inandar, he is a student of this course and he has helped me pursue this particular structure. Okay, and this is the beam column grid, and all the sizes and are taken for this beam and column are this conventional and basic. Okay, and this particular part is again very interesting, wherein we have a composite structure, wherein this particular wall, this particular thick wall of 600 mm, that is 2 feet, is going to be the load bearing wall, and again we have the frame structure, that is the regular and normal beam and column in this portion, which I have been talking about in my introduction, that is an executed project. And this is the very interesting wall, which is starting from its base and its load bearing wall, and it's getting converted into the roof. The making of this, if I just show you, and this is the working drawing of that particular wall, and it's very technical and it has a lot of details in it, and exactly mimicking this and perceiving this in particular thing, executing this particular thing exactly, would be very difficult in Revit, but a simpler version of that has been pursued by me, wherein we have this particular thick wall of 600 mm which is resting on this particular step footing, okay, which will be of entire brick, and also along with that we have these beams at floor level and this particular entire beam at this particular lintel level of the opening, and which is getting converted into the slab. So this red color shows the ground line, and this is the making of this particular portion, this particular part. Okay, so it is going to be a very informative and very insightful and delightful session, so do watch the video till the end. And now, with further overdue, let's jump into the interface of Revit. And while in this home screen of Revit, let me just click new and architectural template, architectural project template, and let me just drag this elevation marker a bit so we can have a free canvas to work on. And simply, without wasting the time, let me just go to insert and import CAD, and this is that particular file which I'm going to say that preserve all, and the import unit should be inch, since the AutoCAD drawing of this is been made in feet inches, and the positioning should be manual center open. And yeah, so we have loaded that particular AutoCAD plan in our Revit environment. And the first and the foremost, I'll go to import categories and turn this to halftone for proper visual appearance. Now the next thing is that what we need to do is that we need to create the various levels. So let me just go to south elevation and press LL and say that 10 foot, pick lines, and yeah, so this is going to be the 0 basement slab. Okay, then we will have another layer, since if you see that we have this particular, if you see this particular section, then you see that this is the 10 foot, but this particular thing is having a depth of 4 feet from this ground level. Okay, so we need to make that particular level. So again LL, and I would say that 4 feet from ground level would be the 0.01 footing bottom. Yes, okay, and this would be the one road level or ground floor, whatever you call, road or ground level. And then we will have a plinth of 3 feet, so that will be the plinth level. Okay, and that should be 3 feet. And let me just 3/16 of an inch, yeah, fine. And actually let's call this plinth or ground level, and this should only be the road level. Yes, and again LL, and now the regular floors, which will be at the height of 10 foot, 1 and 2 and 3, and have 3 floor plates, wherein this would be 3 first floor, and this would be 4 second floor, and this would be terrace level, and finally offset one more level at 9 feet, and that would be the slab top. The reason of following this numeric is that I want this levels to appear in order in this particular project browser. Okay, fine. Now we are exactly going to follow the same process in which the construction will happen on site for this particular project. So the first step is to excavate this much portion of the site and lay the raft footing onto it. So I will just take this particular plan and take it to the basement slab. Okay, and this is that particular plan, and we have to do this a couple of times. Import and turn it to halftone. Yeah, fine. Now I'm going to just go to architecture part, and herein I'm going to create this particular slab and structural foundation slab. Fine, and I'm just going to create this and pick lines TR and join this and this, and I would edit this and duplicate this, call PCC slab, PCC, that's fine, PCC plate. So the first level would be of that particular PCC which would be 3 inches. Okay, and onto that will be our raft foundation. So again we have to create one more slab and structural foundation slab, and this is that I'm going to duplicate this and call it raft, which would be having the thickness of 600 mm, that is 2 feet. Apply and OK, and again the same footprints, pick lines and TR and TR and just finish. Yeah, highlighted floor overlap, doesn't matter. So if I just turn this to wireframe, and where is the layer of PCC? It's here. Why cannot I see it? Let me just drag this bit up and let me take this height offset to -2 feet. Yeah, and then this particular, but it might have lost its alignment. So just modify and align this to this and this to this and find perfect. Let's go to, and this height offset, let me say 0. Fine. And somehow we cannot see that layer of PCC, but that's fine. Okay, let's forget it. So let me just go to 3D and yeah, see. Yeah, fine, that's perfect, not an issue. So the next step is to build the retaining walls. The retaining walls will come on the periphery of this. So let me again go to basement slab, and yeah, this is that part, I suppose. Let me just turn the underlay to basement slab, and yeah, so LI and draw a reference line and then align this part with this part, so we can have that particular walls, which you can just have a cross check in 3D that yeah, perfect. So that is the perfect point where we aligned it. So again, going to basement slab, now we are going to go to architecture and wall, and this time I'm going to edit and duplicate and call it retaining wall, and I'm just going to consider the normal conventional 9-inch size, and as I said before, the exact size will be decided by the structural engineer and its cross section also. So with that, I will just create new material and rename this, call it retaining wall, and copy it. And in the appearance, I am going to go to this appearance library, and under that, this appearance library, I'm going to select concrete and select this particular material. Yeah, this. I'm just going to replace that into the material asset browser, and yeah, fine, sample size is fine. And also don't forget to duplicate here, or else you will end up messing with the, and give it a same name, retaining wall. Fine, apply and OK, apply and OK, and let's go to 3D and CC and R, enter. And where is the wall been created? I cannot see that wall. Oh, but we didn't create the wall, sorry. So wall and the retaining wall, and the constraint will follow this particular basement slab up till let's say that road level, and just pick, and with this finish face exterior, I'm just going to pick this particular one and 2 and 3, 4, 5 and 6. Okay, and let's go to 3D. Fine. So the retaining wall has been constructed, and the only reason of using this pick line command is that if we just delete this and say CS, that is create similar, and if I go to draft, then I might end up snapping to the wrong point or wrong line, and that is the point you might not be able to pursue this particular wall properly and place this wall properly. So better is that you just click the wall command WA and just pick lines and pick this AutoCAD line, and with that you will be able to place it properly exactly in location. Okay, next is that this particular structure will not have the ground beams because it is already resting on the raft, but it will have this particular columns. Okay, so now is the time to load the columns onto this. So let me just go to structure and columns, structural columns. Under this architecture tab also, if you just press this column, then you can access that structural column, and right now it says that only this W shaped column is, so we have to load family. That will navigate to its location, and under libraries, under English Imperial, you have to look for structural column and concrete, and this is that concrete rectangular column. Okay, open, and with that I have loaded that. Now let me just show you one thing, that the normal procedure of this loading columns onto this Revit is that you just click grid lines. GR is the shortcut. Under architecture we have this grid lines, GR is the shortcut, and if I just place this particular grid lines and then say that column structural column, and with that particular concrete rectangular column, if I say that all grids, if I just snap, then you see that automatically this columns get snapped to the intersection of that grid lines. But this is very situational. When we will use this particular method, when we will have all the columns and all the grid falling exactly in the center of one another, so that is not going to help us in this particular case, wherein we have different alignments of the columns and the placement line is also different. So we will just get rid of this grid lines, and we are going to lay this column manually, which again has different sizes. For example, if I just measure this particular one column, this is 2 feet by 1 feet, and this particular columns are 9 inches by how much? 2 feet. So 9 inch by 2 feet and 1 feet by 2 feet 6 inches. These are 2 columns, and also we have the circular columns. Fine. So let's go to structure and column and duplicate it and call it 1 feet, or let's say 1 feet is fine, across 2 feet 6 inches. And for the breadth, 1 feet is fine, but for the height I'm going to say that 2 feet 6 inches. Apply and OK, and with that height selected, and I want to go till road level. Okay, and what I will do is that I will just place that column anywhere. Fine. And with that, now what you need to do is rotate and rotate this. Now it is very important. See, wireframe, and what I can do is that I can just select this point and snap to this point. But again, while laying the columns this way, you might end up snapping to the wrong point or wrong line. So the best way is that go to modify and align that, and you will be exactly loading that particular column onto that point. Now CO, and we have to lay this columns manually, because as I said that the alignment of this columns is different and orientation is also different, so we cannot use that function of grid line on this. So enter and place this, and see, again this won't snap properly. So the best part is to align, and this face and this with this face. And if you will just zoom in a bit, then we will always see that whatever 3D elements you add to this particular Revit interface, that will not exactly snap to the AutoCAD lines. So, and the problem is that, see, I just drag this particular column a bit far away, and let me press LI, that is line command, and even if I try to draw and if I snap to this particular AutoCAD line, and if I draw this line, then you see that even though we have snapped to that particular endpoint of that particular AutoCAD line, this will have a little bit variation. So that is not a problem, that is just a small glitch, but despite that it will exactly lay this column onto that point, so you don't need to worry in that case. Fine. So this 4 columns were of that size, and the rest, all the columns will be of that 9" by 2 feet. So I need to duplicate this and call it 9" cross 2 feet. For the breadth, I'm just going to enter 9", and for the height, I'm going to enter 2 feet. Apply and OK. So this particular column has reduced its size, and let me just copy it and let me RO and rotate and change its orientation. And again, while going to align, I'm just going to align this particular thing, and wherever we have this column in such orientation, we will just place, and wherever it doesn't snap to the point, then you have to align it, otherwise you might end up placing it at the wrong point. And CO, copy and just copy to this point. Yeah, so here it is snapping, so not a problem. Here too, and here, and this column, this particular column is here. Okay, and one more, CO and align and align. Align and fine. Also 2 more, which are the part of this wall, but those columns will go up, even though this is the retaining wall, but this columns will go above the level of the end, above the top of this particular retaining wall. Fine. And the last part is that we have to add this circular columns. So for that, I'm going to again go to structure and structural column and load family and concrete round column under the same folder, that is libraries, English Imperial, structural columns and concrete. We have this concrete round columns. So just open, and with that 12". I know that the diameter of this is 18 inches. So first let me duplicate it and call it 18 inches. 18 inches already in use. Yeah, so Revit has already defined that, so not an issue. We can directly place it. It is not even 18 inches, it is 2 feet, I guess. So yeah, it has the 2 feet. Fine. Now how to snap to the exact location, because here we cannot use the align command. So what I did is that I have tricked Revit, wherein in the AutoCAD plan I had taken this particular this particular center of this circular columns for reference, which you can see. You cannot see it in here, that's the different plan. Anyways, the concept is that when I select this M, enter, then I can snap to the midpoint of this. But for this particular midpoint, I have drawn the AutoCAD 2D lines for all the circular columns. And with that, again, I would not be able to exactly snap it. This is a bit tricky and annoying, but we have to find the way out. So let's now align it with that reference 1 and 2, 1 and 2. Perfect. So CO and with this point to, again we cannot, so just lay it and then align it. Okay, so with this we have, if I just go to 3D, then you see that we have all our columns laid perfectly till this particular road level. Okay, and let's add the lift shaft and basement plan, and the thickness of which is, it is going to be the concrete walls, and due to some reason it is not, 6 and some oddly fraction, so it doesn't matter, at least this is complete 6 inches, so not a problem. Let me go to architecture and wall and duplicate this and duplicate this wall and call it lift shaft, and edit, and it is going to have a thickness of 6 inches. Apply and OK, and draw, and instead of drawing you can just even snap to the lines, but this time I'm going to use this particular finish face exterior and snap. So what are the constraints? The constraint that we entered are the basement slide up to the road level. Yeah, fine, that's better. For this particular walls, we will have to say that where is it? Columns. No, sorry, not columns. Walls, and the same wall, but we will have to snap to the. We have to pick lines, since I ended up messing with this AutoCAD plan wherein I don't have exact 6 inches. So pick lines. Sorry. Walls and pick lines. Yeah. Walls and pick lines. Beautiful. Fine. This too will also be that particular same wall. Yeah, this actually, in this case, this particular wall will go to this end, so not a problem, because anyway it is a concrete and retaining wall only. Fine. So let's go to 3D. Okay. Now there are some junctions where we need to join this particular. So join, and join this to this, join this to this, join and join. Yeah, fine. Okay, so there is no point of applying the finishing material to this exposed column, because anyway this portion is not going to be seen. This is the retaining wall and this is the soil. If you remember that we have excavated this particular entire portion. Okay, so we have to move very slowly and technically. And now if I just go to this section, next is that we have to design a ramp which will be going from road level up to this basement level, and that you can do here itself in this particular basement slab floor plan. Okay, so while architecture, I will just go to ramp and edit type and duplicate and call this custom ramp, and the maximum incline length I'll turn it to solid, and this are to the most important variables. And the maximum incline length in this case is, I know that this is 60 feet and I want to cover the distance of 10 feet within that. So this variable I have to define 60 divided by 10, that is 6. That is the factor. So 1 gem 6 of a ratio, that is a bit less. Actually that should be 1 gem 7 according to standards, but that's fine for now. And just click apply and OK. And with that run, I will just draft from here till here. So it says that 9 feet of incline ramp created, 27 feet remaining. So I will just, from basement level up till road level. So 9 feet of incline ramp created, 51 feet remaining. So again run and click this point and it will exactly end up here. Okay, and what we just need to do is adjust the boundary lines, and this should go here and this should go here. Yeah, delete element, doesn't matter, and just delete this and tr and join this. Okay, and hopefully everything is fine, and just edit type and give it a material. And again I'm just going to duplicate this duplicate material asset and call it ramp material, and duplicate here in appearance as well and call this same ramp material, and appearance library and concrete again, and this concrete ribbed, where is it? Yeah, here it is, vertical. And after replacing we need to duplicate it and call it one ramp material. Just sample size to something drastic like 6 feet. Done, apply, OK, apply and OK and finish. Yeah, so let me just get rid of this railings and just see it in 3D. Perfect. So we have our ramp going from basement up to this particular road level. Next step is that if you just closely observe this particular floor plan, then what you infer is that of this entire site we have excavated this much portion in order to provide the basement. But if you just take yourself to this particular ground floor layout, then here there is a 6-inch of a hardscape, and this too is a ramp, and here through there is a plinth, and the beam grid over here is being laid at parking level, that is the plinth of 3 feet. So what my point is that you have excavated this much portion onto which you are going to lay the plinth and ramp. So to support that, we need a floor plate, we need a base plate which will have the tie beams which will take the load of that particular floor plate. Okay, so let's just do that. And while going to this structure and beam, it says that W shaped, we need to go to load family, and under this particular English Imperial and structural framing, here it is. We have this concrete and concrete rectangular beams. So just open that and edit type and duplicate it and call it 9" cross 18". The exact size of that again will be taken. This is just an assumption and a consideration. The exact size will be decided by the structural engineer. Okay, and apply and OK, and with Z justification to bottom, since we can visualize that what we are drafting. What I will do is that I will just pick lines. If I draw a line, then if I can even draw this particular beam from this point to this point, but you might end up in snapping to the wrong line or wrong point. So the best way is that click beam and just pick lines and draw this. And no, but again pick lines, and you need to have your Y justification to left or right. That is a trial and error. So in this case, yeah, so see, you should have provided the right. And pick lines, yeah, perfect. And onto this also we will have a beam. Yeah, that's perfect. And this will go up till this particular end, and this from here it will extend. And here we don't have AutoCAD lines. I forgot to draw the lines, so we have to draw it manually. And this, and from here to, we'll just place it, then we'll align it later. Not an issue. And this will actually go through this end. Fine, and just modify and align this to this, and align this to this. Okay, and snap this point to here, and likewise snap this point also here. So this will be the tie beams. This will be the tie beams which will onto which the floor plate at ground level, at road level, that particular floor plate will be resting. This particular floor plate will be resting. And also we need one more tie beam here from this point to this point, and again modify and align, and or just snap move and from this point to this point. Okay, so let's see it in 3D. Oh, we created that at wrong floor plan. And just select all of them, and SA, that will select SA, will select all of that beams, and just change that edit work plane, and just change them to road level. Okay, and you see that all of that has been elevated to road level. Only thing is that we need to change its Z justification to top, which I kept bottom since I just wanted to visualize that what we are drafting. Fine. So this pertains to the beam and column grid at ground level, but if you just I guess that we will need a beam onto this particular edge also. Let me just take you to the floor plan to make you understand this. So if you see that we have excavated so much portion of the site, fine, and to lay this particular hardscape, as I just showed you in this plan, we provided the tie beams onto this particular faces. Okay, but this too is going to be the backyard, which will have a base plate. Okay, because this portion is excavated, so we again need to add one beam onto here and a couple of tie beams onto here to complete the geometry. So let's go to structure and beam and pick lines and pick this. Okay, and that's fine. And again beam, and let me draw from this point to this point to this, and from here to here, and yeah, and only make sure that this is at this point. But all of these beams we have created at wrong level, that is basement level, and just select all of this and pick new, or set that sorry, not pick new, 1 2 3 and 4, and edit work plane, and right now it is basement level. See, I'll just send them to road level, and now if you just see it in 3D, then yeah, you have a perfect connection. Only thing that what you need to do is that I drawn them with Z justification bottom to visualize it, just change them to top, and yeah, perfect. Okay, so with that we have completely done with the structural part for ground level, only ground level. Okay, and now let's quickly lay this particular hardscape and base plate onto this portion. So let's go to road level, and now we don't need that particular the AutoCAD plan to that particular level, so just go to basement level and select this particular AutoCAD plan and change this to road level, and onto road level VG, imported categories, turn it to halftone, apply, OK, and yeah, that's fine. But only thing is that you need to align this, align from modify and align, and this point to this point, and let me see whether the AutoCAD plan is matching or not. We don't have any errors. Yeah, fine. It is very important for you guys to check at every point that whether the AutoCAD plan has been laid perfectly or not, in order to match the geometry. So let's create the base plate for this particular hardscape at road level. And so let me just go to floor and floor architecture and edit type and duplicate it and call it road level base plate, and that would be just 3 inch, that is 75 mm of PCC, that would be laying on that longitudinal beam and across this tie beams that we just created for the hardscape at road level. And let me just create this, and not this line, the internal lines. Okay, and just finish it and don't attach. Just like we created the base plate, here we also need a base plate at this level. And also I would like to bring to your notice that these two particular walls, that is the retaining walls, for the construction of this retaining wall we need to do the shuttering, for which we need the space of minimum 1.2 meter, that is 4 feet from this walls. So we need to excavate this much portion of the soil, and then once the job is done we will have a backfill, and then the compaction will be done up till the ground level, up till the road level, and then onto that the layer of PCC, 3 to 4 inch of PCC layer with the finished floor material and mortar will be laid, which will be having some finishing material of Kota stone or whatever. So let's create that floor as well, and boundary line and edit type and duplicate and call it entrance Kota. Okay, and edit type, and yeah, 3 inches enough, apply and OK. And what we'll do is that just pick lines and TR and join this, and very important, give it a height offset of 3 inch, assuming that after backfilling we have come up to this particular road level 00 level, and whatever we are laying onto that. So just finish and TR and finish this, and yeah, and don't attach. Okay, so let's see it in 3D. Yeah, the only thing is that we need to create this particular one wall, so that we can create here itself in road level. And by clicking wall, I will just edit type and find a generic 8 inch and duplicate that and call it main wall 9 inch. And onto the structure I will just give it a thickness of 9 inch, that is the basic conventional 230 mm wall. And herein I am going to create a new material and create new material, and yeah, default new material, and just rename this, call it one main wall, or let's say that wall paint. Okay, and just copy and on the appearance I'm also going to duplicate that and paste and just give it a white color, paint, simple paint, white, and make it appear like a wall. Yeah. And in the graphics for the cut pattern, I'm going to use something which appears like a brick. You can also load an AutoCAD pattern onto this, but right now, just to save time, I'm just selecting something which looks relevant. And with that, I'm just going to say apply and OK. OK. Apply and OK. And for the constraints, I'm just going to use the base constraint to, let's say, that basement slab, and I would like to make it go till road level. And here only in this particular road level plan, let's give it a offset of 3 foot. Yeah, so we can see that what we have drafted. And from here, let's press space. By clicking space, you can flip the direction, and I will just make that particular wall. And let's just go to 3D and see. Okay. Now at this point, I would like to bring to your notice that if I just remove this 3 foot of offset, and if you see the join condition, then right now the architectural elements are getting embedded or overlapped with the structural element. So if I just go to modify and join, and if I join this beam with the wall and then the column with the wall, then what it does, that it will take that much portion of the wall and create a visual appearance just like this. And if we ever take this wall above this particular level, then the structure will be visible, but this is not what we want. Okay, so I'm just going to bring to your notice that even whether it is floor or wall or column or beam, any structural element, that should wrap with the architectural element in such a way that the structure part should not be visible, and it should have the corresponding layers like that. So if I just take you to this AutoCAD plan, then what you see here is that we have an RCC slab of 150 mm, that is 6 inch thick RCC slab. But onto that, depending upon the function and the level, this dimensions may vary, but the concept is that onto that particular RCC slab, the first layer is that will be of that PCC or sand bedding. Okay, then next is the 12 mm thick mortar, and onto that will be our 19 mm finishing material, that thick tile. Okay, and likewise for wall also we have the external plaster and the internal plaster. The external plaster is 19 mm and internal plaster is 12 mm. So because of this wrapping, when you see from exterior, so nothing, the structure won't be visible. So this is very likely possible in Revit, that we are going to do now. Okay, so I will just delete this wall, and to achieve that, what I'm going to do is that first go to manage and materials, and first create a couple of materials. Okay, and for that I'm just going to duplicate this and call this one plaster, and that will have the same appearance, but I need to duplicate it and rename. But for this graphics, we won't have any cut pattern, because it would just be a extremely thin layer or of say 19 mm or 12 mm, so small sliver it will be. So I will say that no pattern. Okay, next is we are going to again duplicate this particular wall paint, and this time I'm going to call this brick beds. Okay, and I'm just going to copy this, and for appearance I'm just again going to duplicate this and call this brick beds. Okay, and this layer is actually not going to be seen, it will be used for waterproofing in floors, so we don't need to apply it an appearance, let it be what it is by default. But under graphics I will just change this cut pattern, and this time we don't have a pattern which looks like a appearance of a brick. So in that case we are just going to new pattern and call it brick pattern. Brick pattern. And this time I'm going to say that custom and browse, and I will browse to that particular location wherein that AutoCAD pad file has been saved, and I'll just open up that pad file and I have all my AutoCAD hatch and I can use any of them. So import units, import scale just 0.5 and fine, and this is brick beds. Okay, next is again I'm going to duplicate this and call this one sand bedding or PCC. Okay, so we can use for both of this, and just copy and again duplicate and call this sand bedding or PCC, and somehow it doesn't allow us to rename, but that's fine, it has already renamed. And under graphics I will change this pattern to sand dense. Okay, fine, apply. And again this time I'm going to create this, again duplicate this and call it one mortar and copy, and under appearance I'm going to duplicate that as well, and I wish it would allow me to rename. Yeah, fine. And appearance, again this layer won't be seen, so just change the cut pattern and make it equal to this gypsum plaster. Fine. And apart from this, I know certain materials which we are going to use for this particular structure, so just for the conveniency I will create those materials before escaping out, and create new material and rename it, call it one compound wall, and copy and duplicate and name it compound wall as well. And this time I'm going to select the image, and for image I don't want to use the materials of AutoCAD, but I have segregated certain seamless textures from internet which I'm going to use for this particular, and open and just change its pattern to something like tiling to 10 feet. Okay, fine. And color is not important, whatever it is, fine. But this would also reflect the cut pattern of brick, because it is going to be a brick wall irrespective of whatever is the material. So no, actually this compound wall material will be applied as an external layer, so this wouldn't have the cut pattern. It will just be a small sliver of that material, which would be a 19 mm or 12 mm tile. Okay, so that's fine. And one more material, create new, and again rename and call this one stone wall. And again I'm just going to select this, copy and appearance, duplicate, paste, and load an image from there only, and this is going to be that material, and also give it a tiling of 10 feet. Okay, and done. And make it appear like a wall so you can properly visualize. Yeah, fine. And same as this compound wall as well. Yeah, okay. What else? Some of the flooring materials also I need to create, so let me just create new material and call it rename one main, or let's say plinth flooring, plinth finished flooring. Let's be specific. And again I'm just going to copy this and duplicate, paste, and yes. And for this I'm just going to select this particular image and no, actually not that, yeah, with that only, fine. And change its styling to something like 5 feet. Done. Apply. And two more materials, that is create new, and let's call it rename one stone, black stone. And copy, and in the appearance duplicate, and I don't have actually any material corresponding to that, so we will use the appearance library of Revit and the appearance library concrete, and this particular any of this, there are those stones, yeah, just use this, yeah, fine, okay. And duplicate, and don't forget to, yeah, black stone, not block stone, black stone, and yes, and change the styling to something like 5 feet. Done. And rename here as well, black stone. And one more last, and that would be essentially one amphitheater. And duplicate, and okay, and just load the image, and this time I am going to select this particular where is it, where is it gone? I cannot see it. It is supposed to be one of this thumbnails, and yeah, this is it. Okay, open, and just give it a tiling of 5 feet. And done. And apply, and okay. And yes, also we need to create the finishing material for this basement, so one more material, and create new material one. The only reason of doing all this work is that later we can just apply, create the 3D element and just quickly apply. So one, and basement finish flooring, copy, and under appearance duplicate that and paste, and just select the image, and from this I'm going to select this particular image, open, and change its styling to 5 feet by 5 feet. Done. Apply, and okay. And a lot of materials defined, and now we should start the modeling part. Okay, and let's go to architecture tab, and if I just take you to this section, then what you see is the section of that particular floor plan, wherein if I just turn on this line weight, then this is that particular raft onto which that entire structure is resting. Okay, but this raft is in unfinished state right now. As I said earlier, all of the structural elements are right now in an unfinished state. So with that materials defined, now we are going to lay the layers of the actual materials that are going to be applied to that particular finishing materials. Okay, so let me just go to foundation slab, and if I just turn this, fine, yeah, see, so this is concrete and the cut pattern of concrete, and the PCC layer is not being seen. Let's just go to C3D. Yeah, that is because the homogeneous material has been applied to both of this. So for the PCC plate, let me just go to edit type and edit, and give it a material of PCC which we have already defined, so that will differentiate it. And where is it? Yeah, sand bedding PCC, which has the appearance of white color and graphics of cut pattern the sentence. Okay, apply, okay, and that will differentiate that layer of PCC even in section. Fine. Okay, so now what we need to do is that onto this raft foundation, we need to define certain layers. So let's go to insert, not here but on the top, 1 2 3 and 4, and all of that I'm just going to call this finish 1. Okay, and this I'm going to call 100 mm, but since it is basement, so actual dimensions will be decided as per the structural requirement, but right now I'm just considering the ideal situation, and this will be the layer of brick beds for waterproofing. Since it is a basement, so a lot of water is going to penetrate there. Okay, so another layer will be the sand bedding or PCC, what will we call, and that would be just 20 mm. Okay, for a uniform surface, so that would be sand bedding or PCC, which has a cut pattern of sentence. Okay, and then will be the layer of mortar that is going to be 12 mm. And where is mortar? Yeah, which has the cut pattern of just some plaster. And finally will be the finishing material, that is 19 mm of tiles, stone tiles. That is, we have already defined that basement finish flooring. Okay, and let's apply that. Sample size should be 7 feet. Okay, apply, okay, okay. And now if you just see that all these layers onto that unfinished RCC raft, all this finished layers of flooring has been provided, and apply, okay. And now if you see, then this particular slab is, we need to elevate it with this particular finished material that we have provided, and just in, and you can switch between units while working in Revit, that is from imperial to metric and vice versa. And apply, and let me just measure this, 151. Okay, so I'm just going to select this and give it a base offset of 151. What are the project units? The project units are meters. No, I want it to be millimeters. Okay, apply, and then give it a height offset of 151. Let's measure it. Yeah, 151. So why is it now? Yeah, it has elevated. It has elevated 151 mm, and the only thing is that you need to change the scale to properly visualize it. 1 gem 20 or 1 gem 50. Okay, and for this particular material, brick beds, and I'm going to change this particular edit and import scale to even less, 0.25. Okay, 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 apply, and okay, fine. So you see, this is the layers that are going to be on that particular raft. Fine, but now we need to join them all. For example, this edit sketch and footing bottom knee basement slab, and it has a little bit glitch. Yeah, and on this end, yeah, it is perfect. Fine, so again go to section 1, and now turn on thin lines. Fine, and you see at this level, so modify and join, and yeah, this is the join condition. Okay, so this is the particular join condition which I wanted to show you guys, that onto this raft slab, RCC raft slab, there will be so much of finishing layers, and which is this wall, retaining wall, and the material is this, which should have a cut pattern of concrete. Okay, apply. Okay, one and okay, fine. Okay, so now if you just road level and take this section to this point where exactly where the columns are being getting cut, then what you need to do is that I'll just do this for one part, but you need to do it for all of them. Yeah, join and join all of them, but join and switch order, since this column should go till the raft, and yeah, the finished floor material should be seen on that particular thing. You need to do it for all of this. That is one, and also this part. Okay, so see again, join and join all of them. And switch order. Okay, fine. For the rest you can just do. I'm just showing you the conventional method. And this concrete has the surface pattern, which is a bit annoying, so let me just change this material, and you do duplicate it before doing these changes, but right now, just to save time, I'm removing this foreground pattern to none. Okay, and I just want to see the cut pattern. So yeah, so now it looks much better. Okay, likewise, now let's again go to road level and take this plan to actually we can do it here itself. What my point was that now we need to lay this wall with its perfect layers. So if I just go to architecture and wall, then this main wall 9 inch, if I just edit type, then onto its structure, what you see right now is nothing but this, its thickness, but there will be the layer of plaster added to it. So we have to do that. Okay, and just insert, and just like the floors, we also need to add the layers over here and insert down, and this should be finished 1.5. And it doesn't matter, this the bifurcation just given by Revit means that the finished 1.2 should be on the interior side and the finished 1.4 should be on the exterior side. Except this membrane layer, you can shuffle between any of these layers. It doesn't make any difference. It's just the typology defined by Revit. And this should be 12 mm, or let's say 0.5 inch, that is 12.7 exact, and 0.5 inch. Fine. External plaster would be 19 mm and internal plaster would be 12 mm, but right now I'm just taking an ideal situation. And onto that we are going to add the material of plaster. So see, now we don't have to waste time in making the materials. We have made a lot of materials, so we can just apply to the 3D elements and we can concentrate better on the modeling part. Now with this, I will just change this road level, this constraint to basement slab, and the top constraint to, we will construct it up right now up to just road level. Now when I start drafting from this point, what you notice is that it is adding, let me just turn on this thickness, it is adding the external layer, and this should be core face exterior. Since we have added the layers plan, and yeah, since we have added this particular 2 layers, now this location line should change from finished face exterior to core face exterior. Okay, so that will snap to the exterior of the core. And now if I just snap this, then you see when I draft, it is creating the layer of plaster as well. And that is the exact way this particular wall will get constructed, and till here. Fine. Let me raise this section a bit over here, and if I just go to 3D, then right now what you will see, we selected the wrong constraint. What? Yeah, we forgot to, after changing the location line, forgot to change the constraint. So the base constraint should be basement slab and top constraint should be road level, not road level. And right now let's just say that, yeah, road level, or let's say that road level but with the top offset of 0. Okay, so now you see that the layer of that plaster has been wrapped with the structural elements and you cannot see the structure anymore. But what you just need to do is go to basement slab and join these geometries at various points. Okay, and 3D and wall and this layer. Okay, and also we need to join the structural framing with the wall, that is beam. So select this wall, watch here, this point, select this wall, the basic wall 9 inch, and then select the structural framing. Okay, perfect. And this is the exact way it will appear, that structure will not be seen and your structure will be hidden, and what you see, the finished layer. Okay, but in section 1 just we need to make cutout of this. So at this point I will just select this particular wall, edit profile, and I will snap to the lines, and from here I will just move 0.5 is the layer of plaster, and just finish. Edit split lines, edit split, join this with this and this with this, since we edited the profile, so lines cannot be, yeah, TR, and yeah, finish. Okay, and done. Perfect. Now if you just see it in 3D, then you see it is perfect and you cannot see the structure anymore. But I guess that we deducted more part. So again, go to section, and this should actually snap to this point till here. Due to some reason it's not snapping, but that's not an issue, a small glitch. Okay, fine. Now you need to add, so you see this finishing material, the finished flooring material of that particular basement level finishing material is being seen now. What you need to do next is that all this structure is right now in its unfinished state, so you need to add the finishing material to that also. Fine, so let me just go to road level, no, not road level, basement slab. Yeah. So just like structural columns, if you just on the architecture tab, if you just drop this down, you have this architectural columns. Okay, that will just act like a wall and get wrapped with that structure part. So I will just edit this type and duplicate this and call it, right now it is, the dimensions are in mm, so let me just change this back to feet and fractional inches. And this is the best part, that you can switch between working units and column architectural and edit type. And since I know that this particular column is 2 feet 6 inches by 1 feet and this column is 2 feet by 9 inch, so there are 2 categories of column, okay, on this particular floor. So I will just define both of them. So I will just duplicate this and rename it, call it 2 feet 7 inches cross 1 feet 1 inches. Okay, so I have to add the layer of plaster ½ inch on both the side. So that's why if the structural column is 2 feet 6 inch wide, then for architectural column we have to enter this size 2 feet 7 inch, that is 1 inch larger. Okay, and for the depth I will just change this to 2 feet 7 inches 7, and the width, oh sorry, the depth should be 1 foot 1 inch and the width should be 2 feet 7 inch. Okay, apply and okay. And likewise, if we are doing, then let's design the other also. other part also. So that would be 24, so 25 inch, that is 2 feet 1 inch cross, 9 inch, so 10 inch. Okay, and under this I will enter 10 inch, and the width I will enter 2 feet 1 inches. Apply and OK, and I will use this particular 2 feet 7 inches cross 1 feet 1, and the height, this should go up till road level, and just place that, and even place that another one column architecture, and 2 feet 1 inch, so this is the smaller size. Okay, now what you need to do is that modify and align this face and align this face. Okay, and let's turn this to fine and to hidden. Okay, and select that rectangular architectural column and just 0.5 inch and 0.5 inch in X. Okay, fine, and likewise, yeah. So now let's just align this one. So align and this face, align and move 0.5 in Y and 0.5 in X. Okay, perfect. Just by making these two columns, going to 3D, and for this rectangular column, I think that I need to define material. Right now it is referencing concrete, so I need to select this wall paint, apply and OK, and this column, this also I send wall paint, not actually wall paint, sorry, plaster, because if I select this wall paint, then it will reflect the cut pattern of this. So plaster, if you remember, we had defined that particular material plaster, which is same like appearance like a wall, but it doesn't have the cut pattern or foreground pattern. So plaster and copy, apply, OK, and to that column also edit and paste plaster, apply, OK, fine. Now what we need to do is that join, and very carefully, just watch this point, very carefully select the structural column until it reads structural column, and click once and then join the architectural column, and likewise the same thing here. So I guess the dimension of this is not referenced properly. Let me check. And yeah, so this should be 1 feet. Yeah, fine. Okay. Okay. Yeah. So and join and select the structural column, tab and architecture. Yeah. Okay. Just by doing these two things, why is it not adding the plaster layer here? Yeah, so we need to move it ½ inch in X direction, 0.5. Yeah, and now I guess okay, but again it has lost the connection. So join and structural column with the architectural column. Okay, with this, now what you can do is that select all these columns, and just delete it and replace them with this, the one joined with the layer of plaster. So you won't have to do that every time. Okay, so let's just do that quickly, and let's take this AutoCAD plan at basement slab for reference, so we can have something to reference, and select all these columns SA, and just deselect this particular column and delete these 3 columns, and likewise select this column and SA, that will select all that, actually this column SA. Okay, and just deselect this column and also deselect this four columns, because they are already part of the wall and they are joined, so we don't need to touch those columns, but this columns I will just press delete. Okay, and let's go to basement, and again we have to turn this halftone, apply and OK, and just change to wireframe WF, and now we have something to reference, so we can just select this one column, CO, copy, and from this point to okay, just not finding the snap point here. I guess it should just place it, move and select this point and select this point. Let's just check, yeah, it is placed properly. So with this you see that a lot of labor work is eliminated, and just rotate this and move, and just move from this point, snap, take your cursor until you find this point. Yeah, this is really tricky, but you see, if you have to get rid of the labor work, then you have to do this. So copy this and rotate it, RO, and yes, okay, and place it at move, and move from this point to, come on, yes, yeah, you have to be very patient and very careful. So select this point and hover until you find that end point to snap to. Yeah, okay, so that will snap to perfectly, and then copy it multiple times, 1 and 2 and 3, and here we have, yeah, come on, sometimes it is difficult to find the points, but when you face such problems, that select this and okay, and you see it has not snapped properly, so just undo and move this point and snap. Okay, so that automatically it will join, and you don't have to do that every time. And this point again, this time we have to select this edge, 1 2 2. Okay, fine. What left is to add the architectural column for this two circular columns, which has the diameter of 24. So we will have to design an architectural column round of diameter 24.5. So architecture and column architecture, load family, and under this English Imperial you have this columns, not the structural columns but architectural columns, and under that round column, open and edit type and duplicate and call it 24.5. okay, and under this diameter enter 24.5, that is 2 feet half inches, apply OK, and with that height up till road level and on the basement plan just place it. Okay, and with that, when you move, you have an ability to snap to center, because there is a structural column. If there is no structural column and you have to snap to AutoCAD plan, then in AutoCAD plan you should have the center defined like I have did, and like we place the structural columns. And from here, with that round column selected, copy from this point to this point. Okay, and again it is not snapping, so just place it, move, and center and center. Yeah, okay. And let's go to 3D, and you see all these columns are now added with the plaster. And just hide this floor for now. Okay, perfect, absolutely perfect. And what we just need to do is that modify, and just like we join this, we also need to join column and yes, column and yes, yes. Okay, fine. And just like that, round columns, watch here, press tab, structural column with architecture, and likewise tab, structure with architecture. Okay, fine. So the next step now is to add the beams, the layer of plaster to this beams. But how will we do that? Because in architecture tab for column, we have architectural columns, but there is no option of architectural framing or architectural beam. So how to deal with this particular thing? Okay, so the trick here is that you have to create a wall, a false wall, which is having 0.5 inch width more than the structural portion, and then give it a constraint in such a way that it will act as a wall, but then too it will occupy this space wrapping this structural member exactly. Okay, so for that, do we need this architectural floor plan, this AutoCAD floor plan at the basement level, or fine, let's see that where we are going to design that. We are going to design that particular columns in here itself onto road level, and just click wall. Let's try wall architecture, main wall, and edit type, and duplicate this and call this beam wall. Okay, and you know that the width of your beam is 9 inch, so rename this and call it beam wall 10 inch, because on both the ends it is going to add ½ inch of plaster. Okay, and okay, and edit type, and onto this was already 10 inch. Okay, this is already 10 inch, so what needs to be done? Yeah, nothing, fine. Okay, apply and okay, and we just duplicated this because apply and okay, and just change this constraint where it is showing that the base constraint is road level and the top constraint is, just change this constraint to basement slab, and with the base offset of 8 feet 5.5. Why? Because it is having the depth of 18 inches. This particular structural beam is having the depth of 18 inches, so we have to deduct 0.5 of plaster from that, and the top constraint to be exactly road level. Okay, and then place it from this end, press tab, four face exterior, and yeah, so select this point and unconnected name, but I want till road level, basement slab and up till road level. Yeah, fine. So unconnected height of 2 feet, not road level. Yeah, basement slab, base offset 8 feet 5 inches, and yeah, top offset, get rid of that top offset, and yeah, see, 1 feet 6.5. Perfect. So just snap to this X and draw that from here till here, and let's just check whether it created or not till this end. Highlighted lines over. Yeah, fine. Okay, perfect. So you see, but it is having a material of plaster. Yeah, fine, plaster. And yeah, finish 2 should also be plaster. Edit and copy and paste. Okay, okay, apply and okay. Perfect. And you see that for this wall, main wall, also edit type, edit, and this layer should be given plaster material. Apply and okay. And with this, what you just need to do is go to modify and join and select the structure, framing, and the wall. Okay, and likewise this wall with this particular. Yeah, okay, so see how beautifully the layer of plaster is getting added, and we are deducting structure from that. All this will help us a lot in quantification. Okay, quantifying the material, the quantity of plaster and wall paint and everything. Okay, and here too, I guess, no, this is joined perfectly. Yeah, okay, this is joined perfectly. The only thing is that how much layer of plaster this has added. So we need to see that particular thing in section. Yeah, see, perfect, absolutely perfect. This is that particular beam, and we have added. Let's go to basement and take this section. Here, and let's just visualize. Okay, fine, perfect. Okay, 3D. Also, we need to add beams onto this beams. Okay, architectural beams, the structural beams. So again, go to road level, and we will do here itself in road level, just like we did for that face. We are also going to do for this face. And architecture and wall with the same constraint, that beam wall 10 inch and 8.5 and half up to road level, not plinth. Basement slab up to the road level, and top offset 0, so 1.6 and half, and core face exterior, and press tab and just draw from here to here. Yeah, it's not visible here, but we don't even want to see that here. And if we are doing, then let's add this too. Oh, but we don't have anything to reference, so again we need to change the AutoCAD plan in order to have this reference. So modify, align this point to this point, and then architecture wall, and we can actually even pick lines in order to find the alignment with all that same constraint. From basement slab, top offset 8 feet 5 and half up to road level, and pick lines. Let me just pick this one. Even though it is not visible, then fine, we will adjust it once it's created. And this too, here we have to, but we don't have the reference of that. Okay, and oh, it created on the wrong place. Basement and road level. Okay, and now let's go to the ceiling plan of this particular basement slab, so we will be able to see, and therein we can actually snap. Okay, so beautiful, perfect. And let's change this to fine and this to wireframe. Okay, select this one, and again join it to this point. Press space and flip the direction, and with this we just need to copy from this point to this point. Perfect. And place one here and RO rotate. Yes, and move to this point. Move and 0.5 inch. Okay, and just say TR and connect this. Oh no, so we need to manually connect it. Okay, and let's just see it in 3D, and yeah, see, everything is perfect. Just we need to join it. So structural, tab, structure, and yeah, fine, and structure and architecture, structure, architecture, structure, architecture, and structure, and yeah, perfect. See, okay, this three were left off, so again go to basement, and if the orientation of this is the same, then what we can do is just snap it, take it all the way till this end, take all the way till this end, split lines, split and join, split and join, and select this and snap it to this point, select this and snap it to this point. Yeah, okay, and this should be brought here, and this should be brought here. Okay, so these are the beams and the structural framing for road level. Okay, we haven't yet connected all these beams internally because they are going to join at plinth level, so don't get confused with that. And align and select this structure, architecture, structure and architecture, fine, structure and architecture, not join, and structural framing and architecture. Yeah, perfect. So this law. I guess we can extend this wall. No, but then we'll have to deduct, so it doesn't matter. Just select this and ceiling plan of basement, CO copy and snap from this point to this point, 3D, and we snapped the wrong thing. Okay, and redo. Okay, but still this showing. Redo, control Y, join, and tab, structure with architecture, structure with architecture, fine, and just select this and go to and CO, copy from this point to this point. Okay, now it is done, and join the structure with structure. Okay, so finally we are able to create so much, but this is just a one-time work. You will realize in the later part of the modeling that how will this help. Once created, you can just copy it from levels to levels by changing constraint, and with this command, copy to clipboard and paste to elected levels. You'll just witness that. Okay, so now the next step is to HR, and this is the particular part which we need to deal now. And for that, let's just let's go to basement plan and take this AutoCAD place. Sorry, and align from this point, LI, this point, and to this point, but that will not. We need to be very careful while snapping the AutoCAD plan, because even if one small streak of line, small sliver of line gets not positioned properly, then we will have to do a lot of LI and see this point and align. Click this, and actually we have this common. No, okay, align and this point and this point. Yeah, so let's finger crossed and let me just check. Yeah, okay, perfectly. Only this much difference is coming, but that is by default, as I told earlier, that the AutoCAD plan and the 3D geometry will never overlap perfectly and never coincide with one another. Okay, and take this plan and take it back to road level 3D. Okay, so now what we need to do is that HH, and first is that this floor, I need to join this floor 1 to 2 and join and select this floor and join the structural part as well as the plaster layer, both. Perfect. Now what we have to do is that, let me just take you to this plan, and you see that we have a ramp over here going from this level, whatsoever is this level, the finished level over here, up till this 3 foot of a plinth. Okay, so what we need to do is that we need to provide this particular flooring first. So it is resting on the ground level and 3 inch of height offset is given. As I told, that compaction will be done and we will be coming to 0 level, and then onto that the layer of PCC will be laid 3 to 4 inch, which will have the finishing material. So let's do that. So default thickness is 3 inch, and let's just add 2 layers, which would be finish 1/4 and copy and paste. Okay, and this should have a 12 mm. We don't need brick beds over here because it is already resting on ground, and 12 inch, and this is 19 mm. Let's say that this to be, yeah, that's fine, 12 mm and 19 mm. Okay, and all material we have already defined, so this will be mortar for the joining purpose, and this would be the, okay, where is that material? We have not defined what. Stone wall, and okay, so we forget it, doesn't matter. Create new material and call it default new material, rename and call it 1 entrance quota. Okay, quota, yeah, and just copy this, appearance, duplicate, paste it, and color should be white, and this will be an image which I have downloaded, seamless texture from internet, we can apply, and it would be this open, and just give it 5 feet by 5 feet, 4 feet by 4 feet is the standard size for quota, 1200 mm by 1200 mm. Apply and okay, and the total thickness of that goes fine. Apply and okay, and let's just see it in 3D. Oh, beautiful, but that tiling seems a bit annoying, and I need to change that to, let's say, 15 feet by 15 feet. Apply and okay, okay, apply and okay. Yeah, so that looks quite realistic. Okay, And now we need to provide a ramp starting from this finished level, this small sliver, this finished level up till the 3 foot of plinth. Okay, but before that, actually let's add the plinth, so we will be properly able to reference that. Okay, and for adding the plinth, now what we need to do is that we need to construct 1 feet 6 inch of a wall. Let's see the section, road level. Okay, and we have come up till this red line, that is the ground level, and now we need to construct so much of walls, and then again we will have a beam. Okay, and onto that all we will have this structural connection, all these beams, peripheral beams as well as the intermediate beams. This particular all beams we will have. Okay, so let's go to 3D, and let me just select all of these columns, structural columns SA, and we will move step by step, and from basement level to top level is right now road level, I will just take them to plinth. Okay, and likewise I will select SA, all these columns, and to plinth. Okay, and also this SA, so that, as I said, you just have to do the hard work for one time, and then you just have to change the constraints and everything will work perfectly. Okay, and select all of this SA, and to plinth level select this SA, and all that to plinth ground level as well, and likewise SA and plinth ground level. Okay, the only thing left is that these columns are exposed, but doesn't matter, we are anyways drawing a wall of what, how much. Actually we can just take this wall up. Okay, and plinth ground floor, perfect. And we don't need to create the wall for that. Sorry. And what we need to do is that we need the walls up till the floor level of this, and with that also let's take this lift shaft, all of this till plinth ground floor. Okay, and from till here, till particular road level, all this retaining walls, this 1 2 3, all this were retaining wall only up till this particular ground level, road level, sorry. From now they will be the normal regular walls. Okay, because this retaining wall will have a different cross section and different thickness. Right now we have taken just conventional 9 inch, but that would be actually decided by the structural engineer, civil engineer, because that is the structural concern. But from now onwards, we will, from here in, we will have the regular walls. Okay, so let's go to, let's HR, sorry, and take this plan above to plinth ground level. And no, but actually wall can be constructed here as well. Yeah, fine. So road level, and where is, yeah, we are perfectly, and just go to architecture and regular walls, and this is going to be the regular wall, our main wall. Where is that main wall? Yeah, main wall 9 inch with the plaster layer, but this time the constraints will be road level, base offset 0, and up till plinth level. Okay, and we are going to move very technically and slowly, step by step. And with core face exterior selected, I will just select this, press space and flip the direction, and from here till here. Okay, and from this point, WF, okay, let me just select this point. It is not snapping properly. Yeah, this point. Okay, inside of plaster line, and from this point to this, and from this point till press space, and here, okay, and from this to space, and only till here, because here there will be this lift shaft wall, and here we have this retaining wall up till here, so we'll start from here, okay, and till here. Okay, let's see it in 3D. Absolutely perfect, no issues. And this overlaps this wall. You might be thinking that here is already the layer of plaster which we took up, but as soon as we draw the wall, the layer of plaster which we drew, wherever the face is same, the alignment is same, it will ignore one and accept it, because both are the same category, both belongs to the same category of material, that is the wall. Okay, so don't worry, that will not count a double schedule, and that is not a problem. But what we need to do is that modify and join. Okay, join the structure part, and perfect. Wherever the walls are overlapping, they will connect, ignore one of them, and Revit will not count it twice, so you don't need to worry about that part. Okay, and now actually this wall was supposed to come till here. Okay, because the plinth will be till this part. So go to road level and connect this with this point. Okay, in 3D. Okay, so now we need to create the ramp, but here to joining is left. Join and structure, join and CC, R enter, join this, save. Let me just save before we lose anything. Join again. Yeah, okay, now still it's not joined. Revit sometimes create problems for us. Okay, now it just joined. Simple thing, and we have to. Okay, now if I just take you to the section, then what you see is that this particular flooring, which is actually supposed to start from ground level, and M enter, and let's move it, or let the layer of PCC go below, because anyway the compaction will be done and properly it will be placed. So fine, and let's turn this again UN to, yeah, that's feet and fractional inches. So why is it this showing? Yeah, okay, 1/4, and let's get rid of this 0 and just give it an offset of 12 plus 19, that is 31 mm. Okay, and from this point we need a ramp up till here. So also this particular PCC slab, this needs to be elevated height offset of, let's say, 31 mm. That's fine. So we will have this and edit boundary. Let's go to road level and let's snap that to this point. Apply, okay, don't attach. 3D, okay, and we have the plane surface, and now here there will be filling or whatever, but at least we have a base plate which is elevated till the finished level of this entrance quota deck. Okay, and now we need to define the ramp from here to here. So okay, and now we are going to create the ramp and say ramp and custom ramp. So that is that particular ramp going from road level up to this basement, and we are going to use the same concept. So duplicate and call it entrance ramp. Okay, and with solid and with that ramp material, the maximum incline length in this case I know it is 9 feet and 8 inches, and the distance I need to travel is 3 foot. So 9 feet 8 inches, and you have to convert it into imperial, and then you have to convert it into metric mm, and then divide the height, that is 9 feet 8 inches in imperial in metric system in mm is something, and I need to divide that by the height, and height is 3 foot. Okay, so that will give me the scale factor. I have did all that. You can, I've just now tried now just to save time, I will just do that, and the maximum slope ramp, that will give this particular factor. The incline length divided by height will give you this ratio, this factor, and with that ramp, and from road level to plinth level, but with the road offset of that, the finishing level is 31 mm. Okay, and from the plinth level that will be 3 inches, that is 75 mm. I just enter 3 inch top offset to be 3 inch, because the finished floor level on that plinth would be only 75 mm, including brick beds, sand bedding, mortar, everything, which on the basement was 151 mm, because the layer of brick beds was more there. Okay, because it is a basement slab, so we need to provide more layer for brick beds, more thickness for brick bed layer. Okay, and with that I will just click this point. This point, yeah, and it's not snapping to that point. Okay, and this to this. Okay, and just click and see what happens. Go to section, and yes, delete this particular railing, and you see, absolutely perfect, no issues. It is starting from this point, which is the finished level of this particular flooring at ground level after the compaction, the PCC. No, this is that ground level, I guess. Yeah, so from that particular level it is going to this particular height. Modify and measure. Yeah, 3 inches offset, perfect, no issues. Let's go to 3D, but this point still needs to be road level, and edit sketch. Let's bring it all the way here and apply, and now let's see it in 3D. Okay, no issues, and just edit sketch, road level, and take this here and this to here. Okay, and finish. Okay, now let's create this particular small parapet having a small flower bed, and this steps leading to this particular plinth. Okay, in 3D I guess everything is perfect, no issues. Yeah, okay, so road level, and first let me create the floor plinth of 3 feet till here. Actually this entire thing will be but that would be, I guess, let's move step by step. Okay, so architecture and wall, and this will be the concrete wall. So let's have the lift shaft. Okay. RCC pardi 6 inch. The spic lines from road level and the unconnected height of, let's say, 3 feet plinth and 3 foot 9 inches. Okay, pick this, finish face exterior, 1 and 2 and 3, flip, flip and flip, and component model in place, or not component, floor plate, floor architecture and edit type and standard. Where is it? Or let's just edit, duplicate this. Oh, sorry. Entrance quota, duplicate, call it flower bed. That will just be a small sliver. Actually, the soil will be poured and then plantation will be done, but right now we have to make it appear like a flower bed. So edit type, and I'll just delete all this, and this should be only 1 inch, doesn't matter, and the material should be grass. Grass. Yes, Revit has already defined that material, so apply, okay, fine, apply and okay, and just snap 1, 2, 3, and at road level with the height offset of 3 feet, and finish. Yeah, TR and TR, finish. Okay, and I know that it's perfectly created, so I'm not going to cross check in 3D. What we need to do is that we need to create a plinth of 3 foot over here, and that we will create while with using an alternate method, component model in place and floor. Okay, floor 1, or let me just name it component model in place, floor, okay, and entrance deck, okay, and extrusion, and but with that we won't be able to apply. Yeah, that's okay, fine. Let's not go into the rectangle from this point, actually this point to this point, okay, and just snap to this lines, get rid of that TR and join this with this TR and join this, and this would be having a height of 3 feet. Okay, the material we will decide later once we lay the inside flooring, and once we decide we will lay that later, but right now I'll just create this and then create extrusion, couple of extrusion, which would be thick lines, and 1, 2 TR and join this to this, 0, 6 inches, finish, create extrusion, thick lines, 1, 2, because it is a custom shape, so that's why we have to create all these 3D elements using this model in place extrusion command. Okay, create extrusion, pick lines, 1, 2, 3, 4 TR, 18 inches, TR, and yeah, finish, extrusion, 1 2 3 4 tr, and 2 feet, and the last one, create extrusion, pick lines 1 2 3 4 and 30, 2 feet 6 inches, and fine, we are done. Okay, and now let's go to 3D and see. Okay, so this is how the plinth is created here, but here we are actually going to use floors to create that, and this will also go till the road, the plinth level, and here we will just draw that particular, continue that wall. Yeah, 3D. Okay, next is, before moving forward, if you just closely watch this particular beam, then the layer of plaster has been removed because we manipulated the constraint of this wall. Okay, so we just need to edit this wall a bit, and also we added all these columns, we copied and edited, so the joint condition of it to the unfinished slab has been removed, so we need to do that. So just let's go to section, and where is the section right now? Yeah, let's just take it to this place, and fine, and select this particular wall and edit profile, and this should be till here. Okay, and just finish. So that would have solved the problem. Okay, perfect. And now the columns which we need to join, so let's just check its connection. So every time we have to do this, but that's the only way out. Fine, so join and join. Okay, join the flooring with this, and these columns are not cutting. Just check, they are cutting, so why is it not joining? Let me just turn on the line weight. It joined here, but here it's, I guess I need to switch order. Yeah, join and join this with this. Yeah, perfect. And switch order. Okay, this is perfect, no issues. And likewise, let's go to basement slab again and take this section onto here, and here too we need to join. And join, switch order. Okay, and if you don't do this, then you cannot schedule and quantify it properly. So the structure part should join with the structure part. Okay, so we have to do that every time. This is the circular column, and section 1. Join and switch order, and this one. Join, switch order, and section 1, all of this, join, this is joined, yeah, join switch order, oh, that was all, that was correct. Okay, and this, I guess all of them are perfectly joined. No, they are not. Switch order. Okay, now we are perfectly joined. Join switch order. This RCC wall is not joining because of some reason. Joining, yeah, it did join. Switch order, yeah, perfect. So now we can see, now we can say that it's the join condition in all the case is proper. And if I just take this section here, also the walls, the lift shaft, and join and switch order. Okay, now perfect. Is anything left? These walls, still they are not. Okay, and this, okay, they are joined. Fine, so this is perfect so far. Now what next we need to do is that before adding the floor plate of this particular level, this road level, we need to construct the other part of the structure, which is the standard conventional structure, and come up till this level, plinth level of 3 foot. Okay, so let's just quickly do that. And again, let's just take this AutoCAD plan to basement slab, and not basement slab. In this case, we have already predefined a layer, which is, if you just see this section, then you see that this is that particular layer, which is at some height from this particular bottom slab, bottom foundation raft. Okay, so we actually need to take this at footing bottom. Yeah, it's because the underlay is turned on, the reason that we can see. Okay, so let's close this basement slab and take this section here and let's go to basement slab footing bottom, sorry, not basement slab, footing bottom. VG, imported categories, half tone, apply and OK, and take this particular plan for reference, align and align this with okay, again we want to just make sure that it's properly wireframe, and just turn this off. Yeah, perfect, not an issue. Fine. So now let's design the structure of this particular part, wherein all this are the regular isolated footings, and this is the step footing, and this compound wall is the strip footing, because this retaining walls, after coming up till this ground level, that's converted into the normal compound wall, brick wall, which will have auger column at few distance from one another. And in this case we don't need the beam because it is already resting on the retaining wall, but this column will need a strip footing. Okay, and we'll have auger column at a specified distance from one another, and this is the step footing, and this is the isolated footing, and this is the combined footing. Okay, so let's do that quickly. And in this case I guess that we will make use of grid lines in order to place the footing, because we have one, two, and here, and here, it's not snapping to the center due to some reason. GR grid, let's do that, and then move it from this point to center. Yeah, so sometimes you have to okay. And what is the size of this footing? 86 cross 69. And what is the height of that footing? 200 mm, I guess. Yeah, so which will have a base of PCC first. So after excavation, first you need to lay the base of PCC for uniform surface, and then on that the footing, and then the column. So sorry, 86 by 69. So first is that by going to structure, I will just place the structural foundation slab and raft and PCC plate. We have already defined it, and let's just 1, 2, 3, 4, 5, and 6, and just finish with the thickness of 3 inch, that is 75 mm. That's fine. Let's see where is it placed, and elevation. Okay, see, from footing bottom 3 inch down. Perfect. Again go to footing level, and this time structure and isolated footing, and we don't have, so just like we loaded, we need to the beams and the structural framing and the structural columns, we also need the structural foundations, and we have this lot of different foundations, but we will just use this footing rectangular. Open, and 686 by 69. So isolate it and duplicate and call it 86 rename by 69, and the foundation thickness 600 mm, that is 2 feet, and width is 8 feet 6 inches, and length is 6 foot 9 inches. Apply and OK, and then you see this option. So here is, we will use this particular grid. And for now, right now, just to visualize it, do it a height offset of 2 feet. Later, once placed, we will move it to the desired level. But right now, yeah, see, exactly perfect, and all these foundations are laid once at a time. Okay, and just finish. Right, and let me just measure this, modify, and this is also 8.6 by 6.9. No, this is 8.6 by 7 foot, because these columns are bigger than this regular columns. The regular columns is 9 inch by 2 feet, wherein this columns is 1 feet by 2 feet 6 inches. So that's why this foundation will be bigger. So doesn't matter. And also this one foundation is small, 6 cross 6. So we will have to lay this both independently, and this time we will not use this grid. So structure and isolated, duplicate, 6 cross 6, 6 cross 6, okay, and 6 foot cross 6 foot, apply and okay, and just place it right now. Likewise, edit type, duplicate, 8 feet, which was that size, 8 feet 6 inches, yeah, duplicate, 8 feet 6 inches, cross 7 feet, and onto width we will enter 8 feet 6 inches, and length would be 7 feet, apply, okay, and place 2 of them, one over here and one over here. It snaps to AutoCAD plan also. Anyways, but the better way is to align it in order to and this size is bigger, which is combined footing, 8.6 cross, how much is this, 27 feet I guess. Let's measure 27.6. okay. And as I said earlier, the reason of providing this combined footing is for the shuttering work of this particular retaining wall. We need to dig out this soil, and then we'll have backfill. So this will be artificial soil, so there will be chances of settlement. So in order to provide the strength, we will provide a combined footing over here, architecture and isolated, and this time duplicate and call it 8 feet 6 inches cross 27 feet 6 inches, and the length in this case will be 27 6. 6. Apply and okay, and there we go, fine. And now let's just quickly place it, align it to its desired location, and this, I guess, if to avoid any errors, and this onto here. Okay, and finally now we need to provide the tie beams for this. The tie beams to avoid, and that's a structural concern. So what we are going to do is that measure this 9 inch. Okay, so again go to structure and beam, and this beam would be 9 inch. Its height, what would be its height? I have not provided this I beams over here, but that would be essentially 1 feet. I know that 1 feet till here. Okay, so edit type, duplicate, and call it tie beams 9 inch cross 12 inch. Okay, and the breadth will be 9 inch and height will be 1 feet. Apply and okay, and just change its Z justification. Yeah, with bottom, let's try whether it appears. Yeah, and bottom is perfect. So yeah, 2 times, sorry, and pick this and just drag it all the way till this point, and it will automatically join because it's structure, and CO, and copy this to this, and likewise beam and pick lines, and you need to change its justification to left. Instead, let's just align, and this CO from this point to this point, from this point to this point, but this particular line, and this to this, yeah, but this will go all the way till here. And also we will have a couple of tie beams here, pick lines 1, 2 and 3. This will join till here, and this 2 will move and move from this point to this point. That move, this was not selected. Okay, let's see it in 3D. Yeah, so see, perfect, all the tie beams. So this is the structure part conceived properly, and the last one is very interesting, that is the step footing. So which will have the cross section of this. So I searched a lot, but I couldn't find to place this particular isolated footing. So in this case, we are going to use the different method to place this particular isolated footing, and that is while going to architecture tab, component and model in place, and this time we are going to call foundations, structural foundations, yeah, okay, and call it step footing, okay. And what we are going to do is, let me just check the height, 4 feet, but the footing is only up till here, and then this is the load bearing wall coming till this position. So it will be how much? Modify, and yeah, 4 feet. Okay, fine. This is the top of that particular wall. So this is the bottom of that particular load bearing wall. So 4 feet will be the height. So fine, no issues, and create extrusion, and simple extrusion from 0, and this is the footing bottom level and 4 feet of height, and the material of concrete cast in place gray, okay, and just finish. But this is not that footing which we are looking for. We are looking for a step footing. So in order to create that particular steps, we need to use an alternate method, and that is while going to road level, footing bottom. What we will do is that we will just create one simple extrusion, and will it be extrusion or what? Yeah, we will create void extrusion, and void forms, and void extrusion or void sweep, I guess, sketch path, and this will be that entire path, okay, and finish, and modify sweep, select profile and edit profile, and go to section 1, but we cannot see anything. So what we need to do again is that get rid of this, close this, yes, discard the sweep, and take this section, and just exchange this view range, okay, and again go to edit in place and create void form, void sweep, sketch path, rectangle, finish, select profile, edit profile, and section 1. Yes, now we can see it perfectly. And from this, what we need to do is that create that profile that will go 12 inch and 12 inch, 12 inch and 12 inch, 12 inch, and the center of this, how much is that? Again I forgot. So footing bottom, and this is, we cannot measure it, but I roughly know that this is 2 feet, so this will be 3 feet, so 18 inch we will have to go. 18 inch, and not exactly 18 inch, but we need to have a margin of small sliver, so that would be, just make it 1 feet 5.9 inch, and LI, and just finish it, TR, and have a close shape. So no, actually we created the wrong profile. We need to deduct so much part, so this should be the profile. Yeah, exactly, sorry. And then just finish. Lines must be in closed loop. Yeah, they are in closed loop. Yeah, and we need to get rid of this line. Fine, finish and finish. So that will deduct that much portion, and we will have, but again I guess just let's see it in 3D. You're supposed to give it a height of only, edit extrusion, and height of only 3 feet. Yeah, okay, perfect. Let's see it in 3D, in front elevation. Yeah, fine, okay, not an issue. Okay, so sometimes that happens, you forget things, you forget dimensions, and that's why this happens. But now we have perfectly created that step footing, which are joining with the tie beams. Okay, now there's a time to place the columns, and as soon as we will place the columns, this will be pushed to its required level, that is, it will be pushed to the bottom of this particular thing, this particular, which is actually 4 feet, and that is the bottom, and 2 feet. No, actually this footing bottom level is fine. Yeah, no issues. So we will place the columns at footing top, so we need to define one more level, LL, and that would be, yeah, that would be 2 feet. So LL and offset 2 feet, pick lines, and that would be 0 to footing top. Yes, and what we will do is that we will select all these footings. No, but we can place the columns here also, not an issue. So let's go to that particular level, footing top. We cannot see anything, so we just need to turn on the underlay, range level, and turn level footing bottom. Yeah, fine, that's okay. Okay, and with that wireframe, and now we'll be able to visualize the columns. So structure and what is the 2.6 cross 9 inch, and all of that are same. Only this is 2.6 by 1 feet. Okay, and these are the circular columns. Okay, so structure and columns, and we have already defined that column. One is let's just place this column first, the circular one, 1 and 2, and attached structural foundation has moved to the bottom of the column. Yeah, fine. But what was the configuration? Depth name, height and height up till road level. Okay, and place it because that is the footing bottom level, so not an issue. Center and snap to this point, or actually move, and you need to be very until you find that point. You cannot find the snap. Enter, move, and yeah, and same way move and over until you find this midpoint, and you have to be very patient. Okay, column, and we will, under rectangular column, we will be having that particular 1 feet by 2 feet 6 inches, and yes, press rotate, and again we can use the grid function to place this 4 columns. That will be easy. So GR, and find the center of this, 1 and 2, 3 and 4. And it is very important that the grid should intersect. And this too. And make the dimensions. Okay, and with that column and that particular 1 feet by 2.6 and all grids. Okay, we also need to column and 1 foot 2 feet 6 inches, all grids, and yeah, that has placed, but placed that in the wrong direction. So, and then all grid. Yeah, okay, just press space and that will flip the direction. Okay, and finish. Yeah, and then just delete this grids, don't need it anymore. And footing bottom, and this grid doesn't exist anymore, we have deleted it. So again GR and GR, center 1, 2, CO, okay, and just drag that all and drag this all. And this time column and the smaller size, that is 9 inch by 2 feet, but this is 9 inch by 2 feet 6 inches, so we'll have to define another type. So edit type, duplicate, and 9 8 2 feet 6 inches, and the height should go 6 inch in that case. Apply, okay, all grids, select, flip the direction, place. Perfect. And then isolate category and delete all these grids, HR and just 3D. Okay, select all this SA and this footing level, so let's take it to plinth ground floor, SA, and base level is footing top and top level is plinth highlighted elements intersecting. Top level, I guess, yeah, fine, so that is better. And all select SA, select similar, that is at plinth ground level. Okay, and now we are on that particular height, and this is the way we have laid the footing for this particular the structure which is on this part. Okay, the last thing that we need to do is add the strip footing for that column, and that is again a different method. So what would be that level? Again, where is the AutoCAD plan? HR, VG, and imported category half tone. And where is that strip footing? That is at the ground level and 2 feet below, from 600 mm below that ground level. Just watch it here. Yeah, so 2 feet below the ground level. So what we need to do is that we need to go to the road level or ground level, whatever you say, road level, yeah, road level. And first, whenever you see that under the structure tab we have this structural foundations wall, that create foundations, that is hosted by walls. So in this case, first we will have to create this particular compound wall, and then we will lay the strip footing onto that. What is the height of that compound wall? 8 feet. Okay, no issues. So architecture and wall, and this time not the lift shaft, neither a retaining wall, but we will select a different wall, and that would be main wall, and duplicate it and call it compound wall. 9-inch. Okay, edit type, and everything will be same, only this layer of plaster. For that we will just apply a material of compound wall which is already defined by us, which is this material, red agra stone, and the cut pattern is not important in this case. No, but in the graphics, yeah, it has the layer of wall paint in the center, which has the cut pattern of brick. Okay, but the finished layer is compound wall, that is the material, custom material defined by us, and that's don't need to have a cut pattern. And anyways, it is getting elevated from the road level, so we'll have finished layer on both the end, both the sides, interior, exterior, both. If it is going till the basement, and if it is going below the ground level, then it would not have this finished exterior layer inside, or sorry, finished exterior layer outside, because that will merge with the soil. Fine, apply, okay. And height unconnected, start from road level, unconnected height of 8 foot, and this time I'm just going to pick lines, and with finish face exterior, or no, core face exterior, 1 direction. Yeah, so see, it will perfectly live. Flip direction, flip the direction, flip and flip. Okay, this wall will have the auger column at specified distance. Right now I'm not going to go into the depth of that. We have placed it at road level, and this is already constructed, so you don't need to worry about that. But important is that onto that road level we need to go to structure and define this foundation, and that would be duplicate and call compound wall strip footing, and the width should be 1 inch from here and 1 inch from here, so that is 9 inch plus 2 feet, that is 2 feet 9 inches. 2 feet 9 inches will be the width, and foundation thickness 600 mm, so again 2 feet. This concrete cast in place gray, fine, apply, okay, and you just need to select the walls. None of the create element, yeah, fine, that's okay. Okay, 1 2 3 4, and pops up this warning message with that ugly sound, but that's okay, you don't need to worry, the footing has been placed. And if you want to just visualize that, ZA, and yeah, see, beautiful. Somehow it has not created this part, but the rest has been created. The strip footing or that particular compound wall, but this has not been created, and we need to figure out why. Road level and wall and compound wall strip footing, and let's select that wall. Okay, yeah, now it is created, perfect. And there's a little bit glitch over here, but that's fine, we don't need to go into the depth of that. But anyways, that thing is not going to be seen once the layer of road will be placed. But this is the way you have created the entire structure. Okay, fine. So now we can continue placing that particular floor, because this has been elevated up till this part. Next part is that we need to connect all this construct the floor for this particular plinth level. Let me just take you to the elevation, and we need to construct this particular floor which is at road level, plinth level, plinth or ground level, whatever you call. We need to construct this floor plate and the plinth beam joining all this structure. Okay, so we need to do that. For that purpose, I will just select this one wall, SA, and just for the proper visual appearance, I will just temporarily hide this particular thing, and let's just see the structure part for now. And you see, we need to extend this particular floor plate. We need to create one floor plate along with the plinth beams, which will be joining all these columns. Okay, so let's do that. So again, go to road level, and see, here is that grid of plinth beam. So what we need to do is we need to modify, align, and this point and this point. Okay, and just take this AutoCAD plan. This is at what level? This is right now at footing level, so we need to take that at plinth ground level. Okay, and just footing, top, bottom, I need to get rid of, and just open up that particular plinth or ground level floor plan. Yeah, VG, and import categories, turn it to halftone, apply, okay. So we need to create the floor plate, and before that we need to create the beams that will connect all this structure, plinth beams. So let me just go to structure and beam and placement plinth floor, yeah, fine. And that beam should be 9 inch cross 12 inch, yeah, fine, not an issue. And the Z justification should be bottom. Let's see, let's place one and see where is it placing, whether we can see. Yeah, we can see, so not a problem. And all this beams will be created. We will align it later. First is that let's create it. This is the retaining wall, so not an issue. One over here, and this is created, which you can extend. And yeah, okay. And all this will be extended. This particular thing will be extended here, 1 and 2 and 3, 4, 5, and finally this. Okay, now let's isolate this and this, isolate category, so we will just be able to see that structural framing, that is the beam, and just change this to left. Okay, and change this to left as well. Connect this TR and this to left as well, and this to left TR, and this should be left as well, TR, and perfect. This should go to left, and this beams are having more width, but those are the beams for the first floor plate. Okay, so right at ground level or plinth level we'll have just conventional 9 inch, and actually we can even change if we want, then not an issue. We can make this end here and make this end here, and if this are going to be, let's just drag this, and if this are going to be the bigger beams, because it is taking the bigger columns, and structure and beam, and where is that 1 cross 18 inch, that type is not defined, so let's edit type and call this duplicate, and 12 cross 18. Okay, and 12 inch, apply. Okay, and then just pick lines. 1, yeah, perfect. 2, 3, and yes, let's just change this to left, and this will also be okay, and just change this to left, and then drag this till this point. Why is it not joining? Small glitch, but that's okay. And delete this and drag this till this point for now, and beam with that 1 inch, pick lines and pick lines and pick lines and pick lines. Okay, and this should change its justification to left. And here there is a small glitch of AutoCAD plan, I guess. That's why we are not able to, but doesn't matter, just move it and drag it to this point. so there'll be a glitch here, but that's okay. And likewise connect all this. Okay, perfect. And now you are on the plinth level, so you will need to, there is no retaining wall, so you need to create the beams on the face, this face also, 9 cross 12, and just connect left. Okay, and TR, and this will go up till here only, no sorry, here till this lift shaft, and actually let's take it till here, and once we'll draw the lift shaft, that will deduct, so not a problem. Left, and draw this one, beam, it climbs, and 1 2, this we will extend, this we will extend, and these beams will not come now because they were, I guess, drawn for that particular, this tie beams, these are the tie beams, so that will not come. With this 2 beams will extend, I guess. So left, why is it not joining? Okay, and this to left, TR, and join this. Okay, with this let's go to 3D and see. Oh my god, the big mess we can also visualize. Okay, and select 1 and SA. Okay, let's do it. Deselect. Select this. SA. Okay, so with that various beams drawn in loop, you need to select each one of that and then select SA, that is to select similar, but that has selected this beams also, so we just need to deselect it. And after that, just change this Z justification to top. Oh, perfect. So fine, this is the way we have created the plinth beams, and we need to join that at certain places. So let's just do the needful, modify and join, and very carefully select that beam. Watch here, you need to select the structural element because you want to deduct that much from the architectural element, so you have to select that structural element first. So structural framing, concrete beam 9 cross 18, select that, and this wall. Perfect. And likewise here too, structural framing and wall. Yeah, and this should join with this. Oh, can't be joined with this. Okay, not an issue. And from here, structural framing and wall, but yeah, we haven't created this particular wall, so that's might be, or that wall is 9 inch thick and this particular beam is 1 feet. So see, so in this case we also need to create the wall, or we will add a plaster layer, doesn't matter. So just select that structural framing and that wall. Structural framing and the wall. Yeah, fine. Okay. Where else? Yeah, this structural framing and wall. Structural framing and wall. That is deducting that. So undo and this wall and deduct the structural framing from that. The shaft wall, lift shaft, tab and deduct this. So what we need to do in this case, that just take this beam till here, we cannot visualize that because we have sent it to bottom 3D, and just change its justification to bottom so that we can visualize that. And again go to plinth ground floor and just drag it to this point. Yeah, and join. Doesn't matter. Anyway, you are not allowing us to join. So CO move and move from this point to this point and drag this to this point. Okay, and then change this justification to top 3D. Okay, that's perfect. Only thing that from basement this all structure will be visible in this case. It will not be visible here, but will be visible here, so we need to add the layer of plaster to all this. Okay, and this beams also we need to join because we had two beams over here at road level also and at plinth level also, but here we, in this case, we just have the beams onto that 3 feet of plinth. But this for peripheral walls, this 1, 2 and 3, we have the beams at road level also and at plinth level also, and in between we have the masonry work. So we need to join that. Join and select the structure, structural frame, tab, yeah, and wall. Okay, just like that. Structural framing and wall done. Yeah, okay, that's done. Only here it is remaining. So again, this structural framing and then the wall, and perfect. Next is this 4 particular beams, 1, 2, 3 and 4, which we need to wrap the layer of plaster. But before that, I need to go to the AutoCAD plan and make you understand the construction part of that. And if you just see this 1, 2, 3, 4, 5, 6, 7 and 8, this 8 columns, those are having a larger width than the regular columns, and also the beam width herein is 1 foot, wherein here it is also only 9 inch. So this columns and beams, the structural elements will get embedded within the wall and will join perfectly. But despite of the plaster layer in the wall, this beam and this column will project out, will have a projection because of its dimension, and that has been done purposely in order to show you that how to deal with such situations when you have the structural elements extruding out of the wall, because in this case that will join perfectly. If you remember, we have this wall, and if I just take you to this beam wall, and with this road level base constraint and base offset 1 foot 5.5, that will deduct ½ inch of a plaster, and the top constraint to plinth floor. If I just pick lines, use this, and if I just click this, then this will perfectly be placed, and just by joining modify and join geometry and structure and architecture, and that will perfectly join and embed. But in this case we will have a projection. So how to deal with such cases? So in that case, nothing you have to do, you have to select a wall, and just like that 10-inch beam wall, we need to create one another, duplicate it and call it 12-inch, edit and call it 12-inch as well. OK, apply and OK, and we have a very powerful command. Every time we don't need to go to the floor plans and pick those lines, and we might end up snapping to the wrong line, so we don't want to take the pain of going to the floor plan. We can directly pick lines and just snap. Okay, with that I will just press space, and what this says, the highlighted wall overlaps. One of them may be ignored when Revit find room boundaries. Use cut or join geometry to embed one wall within the other. So here there is already an architectural wall. See, this is the architectural wall which is already existing over here, and we had just for that particular plaster layer, to add that plaster layer to that projection, we created one more wall. So there are two walls now. You see, this is overlapping, so we need to join them in order to avoid the double counting of schedule. So join and select this. Watch here, it says the main wall 9-inch, and then join it with the newly created beam wall 12-inch. Okay, so that will avoid that, and now we have our beam wall only till here, and onto that modify and join the structural element with that wall, and that will perfectly add the layer of plaster only in that much portion. Okay, so this is how to deal with the elements. And now at certain junctions, before moving further, let's join the structural element and let's exclude the layer of plaster. Here we have, then here, yeah, here too we have join, and yeah, get rid of the plaster. Here too, join, yes, come on, join and join, yeah. So where else? Here, and this too, at all the junctions, in order to exactly quantify the amount of plaster that we will need. This is necessary step, and if we are doing it, then do perfectly, otherwise don't do. That is the concept. Fine, and rest everything. If something remains here, no, this is join. Yeah, this was left. Likewise here too. Yeah, see, overlapping volumes we need to deduct. Okay, and why is this beam with the, why is this guy, what is he doing here? Okay, and oh, see, here also we provided two walls, so there was actually no need of this particular main wall because we already have this wall going up. So just select it and delete it. Fine, and take this guy, snap it to this point, and that's perfect now, no issues. Okay, and see, the beam has joined with the column and all that with the elements. Okay, structural elements with the architectural elements. Fine, so what we need to do is that architecture and wall, and pick lines here, here, and here, and this is the smaller wall, so 10-inch beam wall, 10-inch, here, here, and here, and here, here. Okay, at some places we need to press space and properly align it. Okay, and wherever we see the overlapping volumes, just join the geometry. So tab structural framing beam wall, tab, and join this, and this will not be joined. See, Revit sometimes annoys me a lot. Yeah. Okay, and structure, CC, R enter, join structure and architecture, and perfect. Structure and architecture. Yeah, this is still not structural framing with the wall. Yeah, now it is done, and I hope everything is perfect now. And yeah, this guy is remaining, structure and architecture. Okay, this as well. So join structure with architecture. Some point we will have definitely some problem, and in order to get rid of that, so this is that. So this is only in here, so let's snap it. Oh, sorry. Join and okay, and join. Yeah, so only you are remaining left. So architecture and wall, it's 10 inch or 1 feet, I don't remember. Wall 12 inch, pick lines, and yeah, tab. Okay, done. Modify, join, structure, architecture. Okay, and that's perfect. Fine. This space, highlighted wall overlap. Yeah. Okay, again here we have two walls. See, two architectural walls, one joining with the other. So just join. Pick the main wall, 9 inch. Watch here. Main wall, and join it with the newly created beam wall. And yeah, and join, and again join the structure with the new, and we have the perfect. Everything is perfect now. Okay, as far as this floor is concerned, only this is the small glitch. I don't know how to overcome that. Oh, this guy is remaining. Why? This is the structural framing, and this is the main wall. Okay, extend it till this point, or let's join, make one 10 inch, pick lines, and 1 and 2, space, modify, join, structure, architecture, and structure framing with architecture. Okay, join, structure with architecture, and this is for this particular beam, I guess, or for column. For what it is not joining this two. Structure, yeah, okay, and likewise structure, and yeah, okay, perfect. So we don't have anything left over here, and now with this we can lay the floor plate. So before laying the floor plate, let's get this particular thing done, and for that let me just go to road level and first create a base plate of PCC, since this much portion of the ground will be uneven. So to have a uniform surface, we need to do onto that compaction of soil. Some portion will be excavated, some will not be. So we'll do the compaction and then we'll lay the layer of PCC. And for that, now we need this particular align and this point to this point. Okay, and while going to architecture tab, let's click floor and floor architecture. And if you remember, we already have that particular road level base plate which we laid onto this portion, which we excavated, and we provided the tie beams and laid that base plate onto that. But here this portion is already on the ground, so I just have a layer of PCC and that's 3-inch fine. Okay, just pick lines and 1 and 2 3 and 4, and actually not this, sorry, you have to select this, and coming here this will be problem because the AutoCAD plan will never match with the Revit geometry, but Revit is perfect, we'll consider that. And yes, and TR and this to here, and this with this, but this will not join. Yes, let's go to the inside line. Yeah, it's inside only without plaster, and that should come up till here and join with this, but there will be a little bit of glitch because in this case this also should have been the inside line. Okay, and this should also be the inside. No, okay, but still a little bit of, so just don't waste time on that. That's not much important. It's finished. Must be in closed loop. Where is it open? Finish. Oh yeah, just get rid of this line and finish. Okay, and I think we need this compound wall here as well, so let's just continue it. No, but actually continuing it won't help because this particular compound wall has that strip footing which we actually don't need here. So let's just select that and CS, that is create similar, and just snap to this line. Okay, and road level unconnected 8 foot, that's fine. And from here to here, and from here to this point, and also from this point till this point. Yeah, highlighted all the overlap. Okay, fine. I will disjoin you. Okay, fine. Okay, and it has not drawn the strip footing. Fine, thank God. Okay, but I think there's a problem here, and yeah, the problem is that it plays at road level but at offset of 0. But before taking it to let me just make it appear better. That send bedding PCC material have been already defined. Apply and OK, and then remove the offset. Okay, and VG and imported category halftone. And why halftone? Let's just hide it for now. Okay, and also hide this element and join the structure with that. Okay, and likewise here too. Okay, if you are not allowing, fine. And this and okay, perfect, not an issue. And only thing is that join and join this to this, this to this, and just join geometries and join join and floor. Okay, and yeah, okay. CC R enter, yeah, fine. Also, let's hide this wall. Hide in view of all the 3 walls, 1, 2, and 3. Hide in view by elements. Okay, and let's just see this part. Oh, we forgot one tie beam onto here. So let's select this, and not tie beam, sorry. Tie beams, and oh my god, by mistake I created all the tie beams. So just select that one and CS, sorry, not CS, SA, that will select all that particular tie beams, and just deselect this because we have tie beams actually at the bottom of the footing level, and all these beams are regular beams. Tie beams has the depth of only 12 inch, but this regular beams are 12 inch wide with the depth of 18 inch, which we have already defined type, but by mistake I continued this, so it doesn't matter. Just select this. Okay, and that will increase depth, and that's perfect. And now with this selected, go to road level and CS, that is create similar, pick lines and pick this internal lines. None of the, yeah, fine, no issues. Where did it create? It created road level. We want it at plinth, and just edit work plane and just bring it to plinth level. Okay, fine, no issues. Okay, and if you just closely watch this, then this particular beam, let me just take you to the road level, AutoCAD floor plan, and this actually this entire thing, this is the water body. This is the water body, so we will not have a beam over here. Actually, we'll have a parapet, 3 foot of parapet, and on top of that a 4 inch of coping. That's enough. We don't need to cast the beam. So let's go to 3D and just delete that. And now let's create the floor plate for the plinth level, and that would be essentially just 3 to 4 inch of a PCC, and the slab will not be casted. That will be PCC, which will have the reinforcement along the periphery, but right now we'll just have a 3 inch of homogeneous PCC. Okay, and onto that we will provide the finished layers of flooring. So let me just go to road level and architecture and floor architecture and generic. Where is that road level PCC base plate? Yeah, fine, and just edit type and duplicate that and call it plinth or ground level flooring. Okay, and just that right now we'll just keep it default PCC, sand bedding 3 inch, that's fine. Okay, apply and okay, and we will have it all over here. So let me just draft it and show you. So just select this interior edge other than the plaster layer, and just snap to this point, and we need to do a little bit of drafting work now, so just stay tuned. Pick lines and pick this TR and join this. Delete this line and pick lines, so 1 and 2, so TR and join this as well, and 1 2. Okay, and we will have to discard this particular lift shaft and staircase, so again TR, and from here in select this line. Okay, and pick this, so join that with that. Okay, and also we need to from here and this entire profile, and we have exclude this service duct also, and we'll figure out slowly as we draft it, but TR, and this should join here, and this should join with this. Okay, and pick lines, and here to the interior line, and here to the interior. Okay, and this. Okay, perfect. Apply and interior, and this would be the floor plate, PCC floor plate on this particular parking plinth level parking. And let me just finish, and somehow I think that there is a problem onto here, but this will, oh yeah, so let's just finish it for now. Lines must be in closed loop. Where is it open? Oh, continue and TR, just finish. Oh, sorry, that was supposed to be joined, and we need a line over here as well. Oh my god, a lot of glitches and errors. Okay, don't attach. Fine, and let's go to 3D. Okay, perfect. Only thing is that this face needs to be joined. I was getting confused. So how will we take care of this particular junction? If I just make a try to make a close shape onto here. Oh, sorry. Yeah, okay, delete, got it. And just split lines, join this with this, and create two more lines over here. Yeah, that's perfect. Okay, don't attach. Yeah, fine. Go to 3D. That's perfect. Okay, and I think yeah, so this was also supposed to be included. Edit boundary, and just take this line here. Fine, now it is perfect. Don't attach, and let's create the flower bed. Here there will be a flower bed, so architecture, and the same flooring, and not that same flooring, but where is the flower bed? Yeah, here it is. And apply, and inside line, inside. Okay, and place it at road level, and give it an offset of, right now just give it a 12-inch offset. Okay, fine. 3D. Road level and height offset of 1 feet. No, 2 feet. Okay, that's enough. This will be a flower bed. Okay, so now with this, what we need to do is that we need to join all this, but before that, let's create the floor plate for this two and this one also. So road level and flooring architecture, and that same plinth ground level flooring, and let's just be more specific, rename and public. Okay, and just copy CO and duplicate that and call this private. Since we are going to apply a different finishing material, finished flooring to both of that areas, so that's why we need to rename and duplicate and be more specific. So rectangle and a simple rectangle over here, and this 2 from here till here, because here there is a water body, and just finish. And then ask to attach the floor. What is this level? Or see, this is what happens, and just get rid of this 0 and then again go to road level, and yes, it didn't ask to attach. That's enough. Anyways, we were not going to attach it. And edit boundary, and we forgot to include this particular floor. This would be from this point sorry to this point. To the inside of this, and this actually will be the WC. So okay, 3D. Okay, now let's join them in order to have one homogeneous flooring look. So this is that flooring, so we need to join it at a couple of places. So now just stay tuned, because this is going to take a bit of time. Join. Oh, this is creating a problem. Join and Anyway, so that is the exact thing that I wanted. This at this particular portion, because of this particular weird generation, it is not joining somehow. But anyway, the purpose of doing so much of this hard work was that if you won't join, you won't be able to schedule or quantify the floor plates properly. So that because of that purpose, you need to cut the overlapping volumes of that beams and that columns, which are the structural elements, with that floor, which is also again a structural element. Okay, so now with this, if I just select this particular wall and if I just drag this up, then too, even though the flooring is joined, but it is not attached, so that's why this wall will go up and that will cut the overlapping volume of that particular floor plate. Okay, so that was the purpose of doing so much of work. And we have a glitch over here, but that's fine, we cannot stop the modeling part. And now is the time to add the finished flooring layers to all these floors. Okay, but before that, I think that we should have created this with the floor command only, so that we would have been able to add the finished flooring layers. And here there is a problem. And here, see, we have a beam over here, we have a beam over here, wall over here, and also a beam over here, but here there is no beam, so that's why there is a hollow space, which is, so we need to go to road level and create a simple wall over here. Yeah, but anyway, there is a wall, but that is starting from, yeah, so we need to add a beam onto to this particular face. See, just like this beam, WF, and we also need a beam over here. Okay, that would be a tie beam. So just select this, press space, beam wall, and just watch here. until we find that concrete beam, structural framing tie. Yeah, so structural tie beam and concrete rectangular beam, tie beam 12 11 cross. Again, why is this showing tie beam? This isolate category. Tie beam and all of this. So all these beams are not supposed to be the tie beam. Tie beams will only come at this level. So all of this beams, whether it should be, oh my god, so just select this one tie beam and CS, that is, oh sorry, SA, that is select similar. So that will select all these tie beams and just change all of them to regular 9 cross 18 inch depth. Yeah, okay, not an issue. And now we don't have any tie beam. Okay, all of this are the regular beams. The tie beams will only come at this particular level. Okay, and HR, and we should have created this also. So edit in place, and just yeah, but first was that we need to add a beam over here at this point. So create and structure and beam, and that, not that tie beam but the regular beam, and pick lines and pick this and change the justification to left, and we don't need to provide it because anyway that is not going to be seen. But let's just wall architecture 3D, and yeah, this is that beam. So wall architecture, and where is our beam wall? Yeah, this is that beam wall, 9 inch, 10 inch, and pick lines. Pick this, and from road level up till the plinth level. Road level up to plinth level. Plinth level ground floor, yeah, fine. This should snap here, yeah. Road level up to, we were supposed to finish the command first and then change the constraint. I was changing the constraint while that command active. Space. Okay, and yeah, perfect. Modify, join, select the structural beam and structural framing and the wall. Yeah, fine, perfect. With this, now if I just select this particular floor and edit boundary, and let's go to road level, and let me just snap to this edge and using this particular edge, 3D, and just finish and don't attach. Okay, I forgot, yeah, it's overlapping, so you just need to join. So join and select this floor and join again, select this floor, and yeah, also join, and yeah, okay, fine. This is, I don't know why is it creating a problem, so let's unjoin geometry. Okay, let's try it once again. Join and join this to this. Oh yeah, that's gone. Only this is overlapping one, so that's fine. That's okay. Okay, and likewise, just we need to create one floor plate over here for wash, and since it is a plinth floor, plinth ground floor, so that there will not be duct. There won't be any ducting, and not duct. There won't be any drop slab because it is connected to ground, so the pipelines can go from this space. Okay, so let's just go to road level and create one floor plate. Again, architecture and floor architecture, and duplicate this and duplicate and call it plinth ground floor wash, not wash, what should we call this, what do we call that, drops, restroom or just toilet. Okay, and just give it a 3-inch of flooring, and that should be one tile difference, so let it be 2.75. okay, and apply and okay, and just create one floor from here to this point and just finish. We created a wrong window. What? No. Edit boundaries and snap it to this point. Inside. Finish. Okay. And just join. And all the floor plates have been created. Only thing is that now we need to provide a different finished flooring to all of this. And yeah, regarding this particular thing, what we need to do is that this is generic model. Where is it listed? The floor, and I suppose this is one. Delete. Yeah, that was one. Okay, so what we need to do is that to match the level of flooring, what we need to do is that edit in place and just give it 2.9 inches, so we can have the layer of PCC and we can create a floor, and onto that we can have the finishing material which will merge with this particular floor. So fine, finish. And again, in this case we need to edit boundary and just take this road level and take this line here. Yeah, so it's snapping. Okay, and sorry, and just finish. Don't attach. Oh yeah, perfect. So join and join. Absolutely perfect, no issues. And you see this ramp is having a 3-inch of offset. That 3-inch is for the finished floor level that will exactly match. Okay, so last thing, this floor plate for this, we named it entrance deck, so we are going to provide the same flooring, road level, and again architecture and floor architecture, and edit type and public, and duplicate that and call it flooring entrance deck. Entrance deck means entrance deck, because entrance quota is that the area next to ramp. okay, and 3" the PCC, fine, okay, and just pick lines 1 and 2, inside line, and here 2 inside line, pick lines, and 1, 2, 3 and 4, TR, and just finish. Sorry, continue and TR and join this shape. Don't attach. 3D, yeah, no issues. Small sliver is overlapping or what? Okay, just ignore that, fine. Now what we need to do is that we need to provide the finishing layers to all this, and before that we lose something. Let me just save this file, and we will start with this particular thing, public flooring. Edit type, edit, and add, insert 1 and 2, and we will have this one more, okay, and we will have this the total of it is 3 inches, 17 mm, so let's add 19 mm. That will be the finishing material. This will be 12 mm mortar, and what remains is 19 plus 12, that is how much? 19 plus 12, 31, and minus 75, 44. So let's give 44 mm of BBC, okay, and this should be brick beds. Where are the brick beds? Brick beds, brick beds. Where are you? Yeah, here it is. Why are you hiding? Yeah, okay, and this would be mortar, and this would be the finished flooring, and plinth floor finished flooring. We have already made that material, so see, now this will save our time, and okay, okay, apply, and okay, beautiful. And likewise, now you see that this particular flooring, if I just take you to the road level, and let me just show you in section, and see, perfect, absolutely perfect. The join condition, see, you might be thinking that what was the purpose of doing so much of work, hard work, joining and all this, and kitni mehnat ki. So this was the exact formation or anatomy or composition which I wanted to achieve. That is, this is the wall, and on the top of that there is a beam, and there is an unfinished slab, and onto that we have all the unfinished level, finished flooring level layers. Okay, so since this is already resting on a beam, so we didn't provide the layer of PCC. Otherwise, same after this slab we'll have a layer of PCC also for just for the uniform surface. Okay, but since this is not a slab, it's already PCC, so not a problem. This is a PCC layer, okay, and we need to give the offset, and how much of offset? Ugly fraction, so UN and mm millimeter is very new. Yeah, okay, okay, and 74.9. This should have totaled up, rounded up to 75. I might have reading 74.9. Can edit type, edit, 44 plus 12, so 19 plus 12 is 31, and that minus 75 is 44, and that 44 I added. So this should be actually, never mind, just forget it. And how much is that? Yeah, see, 75. Revit behaves strange sometimes. So give it an offset of 75, or not 75 inch. Sorry, 75, and we are in the metric system. So see, perfect, no issues. And this is the PCC layer, which I said that the slab will not be casted, and there will be a layer of PCC on that particular floor. And this is the finished flooring. And see, perfect. Here there is a small glitch, but that's fine, that's not an issue. It's just about editing the sketch and bringing this line here. Edit sketch and go to road level. Take that line to here, apply, finish. Again go to section. See, now merge, but the earlier one was correct, so just finish. Undo. Yeah, okay. So let's go to 3D again. Let's change this back to UN and feet and fractional inches. Okay, and let's go to 3/16 of an inch and 3D. And just like we created this particular flooring, we need to provide the finished floors for this particular entrance deck. And go to edit type, edit, and again insert and insert. And again this is the PCC, no slab. So here the first layer will be directly of brick beds, that is 44 mm we just calculated. And finish 1/4, finish 1/4, and finish 1/4. This would be 12 mm mortar and 19 mm finishing material. And brick beds, where are you? I found you. And mortar, where are you? And the finishing material for this particular entrance deck, have I finished? Have I mentioned I have created that particular floor? No. So we need to create one. So just create, let's just duplicate this. Let's duplicate any of the existing flooring. Yeah, let's duplicate this only. I hate this. I want it to be here like a wall. And duplicate material and asset, and one call it entrance deck. Okay, and entrance deck or entrance foyer. And copy, and appearance, duplicate that as well. And entrance foyer, and browse to this material. Yeah, and this is that particular material. And 40 feet by 5 feet. Yeah, apply, and okay, entrance foyer. Yeah, okay, apply, okay, apply, and okay. Oh, perfect. Yeah, the only thing is that we need to we actually need to manipulate that thing in section. And where is the section? Okay, and again give it an offset of 75 mm. plinth level, ground level, flooring, entrance, deck. Okay, yeah, perfect. So see, no issues. And this filling could actually appear something like concrete. So let's give this material of concrete, retaining wall. Okay, and the steps we will define later. Right now, okay, so this is done. Okay, now next is that this particular floor plates we need to manipulate, and that wouldn't take much of time. So edit type, and did I change this finish? Yeah, so let it be finish 1.4 and copy. I like things to be perfect, so that's why this was not important, but just edit type, and again edit type, and add 1 and 2 and 3, finish 1.4 and copy, and copy again, and this would be 44 mm, and 44 and what next, 12 mm and 19 mm. Okay, and this would be our brick beds for waterproofing. This would be mortar. And have we defined the material for finished basement, finished flooring? And no, we haven't yet defined the material for that. So PCC plinth finished flooring. So let's just do that. So plinth finished flooring, and just duplicate that and call it plinth finished flooring private. Okay, and let's just rename this, call it public. Copy and change here as well, and duplicate and place plinth finish flooring private. Okay, and let's just select any of the materials, and what could be the finishing material for this private areas, and let me just select this because it has the gazebo and everything, so we'll provide this wooden flooring. That would look better. No, but yeah, fine, that's not an issue. Apply, and what is the tiling? Yeah, 5 feet by 5 feet. Okay, okay, apply and okay, beautiful. And road level, and take the section, go to the section and take this flooring and just give it an offset of 75 mm. Perfect. Okay, so 3D, and yeah, this matches. Okay, now what we need to do next is that this is left, so, and if I just go to edit type, then edit, And this actually this particular layer uh, we should have actually created this entire yeah, but we wanted to create a different flooring for finished flooring for this particular thing, and that's why we are given tile drop. But that tile drop should be 12 so this should actually be 2.5. Okay, and then let's create the finishing, and this would be 44 Actually there will be no big beds onto this because this is already resting on the ground, but just to follow the ideal situation and whatever we have done for this, you just need to have a 12 of one tile drop. So otherwise there is no need of providing the layer of brick beds here. So brick beds and this 12 mortar and yes, and this would be the 19 ceramic tiles. So again we need to create one more flooring for ceramic tiles and just duplicate this and call it wash or toilet. Okay, and just copy this and appearance duplicate and paste it, and just this time we are going to assign a material from here itself, because yeah, and that would be under appearance library ceramic, and just place this tiles in this mosaic. Yeah, fine. And now we need to duplicate it, and then just that would be 4 feet by 4 feet. No, 4 feet by 4 feet is too huge for toilet, so it's 2 feet by 2 feet. Yeah, apply and okay, apply and okay, and just give it a height offset of 75 and we will have one tile drop difference onto here. Let's just see, take a section and expand it. Which is that particular flooring? Where is that? Oh, yeah, it's still. This is that portion. No, I cannot. This is plain flooring now. Plain flooring public. Yeah, this is that. Okay, so the tile drop went down. So 75 minus 12, that would be actually, so just move it and move it from this point to this point. Yeah, okay, perfect. So we have one tile drop. Okay, so now without further ado, let's first complete the landscape part of it, because you can see that it's almost 4 hours, but we have not started the modeling of the walls. So let's first quickly complete the modeling part and the landscape part, and for that I'm not going to go into much detail of the technical details. I'm just going to ignore as far as the landscape is concerned right now, and I'm just going to create simple extrusions. Okay, and let's just create that. So this, here it is, and from this point road level, and first let's create this parapet wall and this water body. So architecture, wall architecture, and where is that 9-inch wall, and this time road level, and this should be only unconnected and 3 foot of height, which should have the coping on the top of it, but right now just 1 and 2, and this will extend to this end. join. Okay, and 3D. Oh, I constrained it properly then to road level and base offset of 3 foot, no, 0, and unconnected height of 3 feet. Okay, and also we will have one here. No, here there is that particular wall, so that load bearing wall, so we don't need to worry about that. And just create floor and floor architecture, and this is going to be the just a simple sliver of water body, which will show that this particular thing is the water body, and road level base plate, and just edit type and duplicate it and call it water body, and that would be just a small sliver of 1 inch, and material of water that is provided by Revit, so we don't need to apply and okay and apply and okay, and just create one here and one over here, overlaps, so delete split lines, TR and TR, and give it let it be at plinth level, and just give it a negative offset of, let's say, 2 inch, minus 2 inch. Apply 3D, and yes, okay, fine, no issues. So let's create this other landscape parts, road level, and first is this particular deck, this step. So again we need to go to, this time we are going to create all this particular landscape elements by model in place, component model in place, and let's select the floor category. Since we will have all the soil filling at different levels, and then onto that we will provide the finishing material which we need to quantify, but we don't need to quantify the soil elements, so the generate models for that simple and floor. Okay, and just I'm going to call that exterior pathway. Okay, and extrusion, and from this point on which we are at road level, fine, from this point to this point, and from this point to this point, just delete this TR, and the finishing material will apply it later, but right now I'm just going to give it an offset. The finishing tile will be 12 mm, so let this be, if we want to go up till the height of 3 feet, and this flooring has the finishing layer of 75 mm, so let this be 3 feet. Fine, that's okay, 3 feet, and just give it a default material, default, and we are not giving any material to that. Just change its color at least to white, apply and okay, and finish. Now we have this swimming pool, this particular swimming pool, which is 2 step above, so create 2 more extrusions from here to here, and that would start from 3 feet, and the extrusion end would be 3 foot 6 inches. Finish, and create 1 more extrusion that would be from here till here, that would 3 foot 6 inches, and that would be 4 feet. And finally, last but not least, create extrusion, and this entire thing would be starting from 4 feet, that would be 4 feet 6 inches. Yes, and also we need to create this particular, this So create an extrusion, and that would be from here to here and from here to here. Make sure that you are snapping to the correct line, and delete this and TR, and that would be from 0 to 4 feet 6.5. 6.5 and 0. Okay, and create one more extrusion, simple extrusion from 0 to, not 0 but from 3 foot 11 inches, no, 3 foot 11 inches, 4 feet, 4 feet 5 inches till 4 feet 5 inches 5 until 4 feet 6 inches. Okay, and give this a material of water. Okay, and just finish. And this, there will be a flower bed over here too, so we just need to put the plinth floor. And where is that flower bed which we just drew? Let's go to 3D. No, that was not the flower bed, that was the water body. So we need to draw the flower bed over here. Yeah, let's just set the simple extrusion only. Create, and from this point till this point, and that would be just 0 and 2 inch, 1 inch, 0 and 1 inch, and that would be the grass. It's already there, the grass. Okay, the default material of Revit. And let's create this particular amphitheater. So create, we are at 3 foot level and we need to go to 0. So 1 2 3 4 5 steps. But 5 steps, yeah. And okay, create extrusion, pick lines 1 2, pick lines 1 2 3 4 5. All this will be the soil filling at different level. So 0 and up till 3 foot. So that will essentially match with that particular, yeah. Okay, but not grass. We will right now say that default. Later we will categorize it into different materials. First, let's complete all this. Okay, and road level again, extrusion and pick lines, again that same, but this time this would be the profile. TR and join this with this, and from 0 to 2 feet 6 inches, and now we will be going down. Create extrusion, pick lines, the third step, 1 2 3 4 5, and likewise you just need to stay tuned, guys. And just delete this, TR, trim extend, join this to this, this to this, and this to this, and 0 2 feet. create extrusion, pick lines, and quickly pick lines and TR. Join this to this, and here we have two lines. Okay, so just get rid of this line, and this should go from 0 to 18 inches, and extrusion 2, 3, 4, 5, 6. This will join, sorry, this will join with this. 0, 12 inches, and finally this part. Are we going correct? Yeah. Okay, but all of this shouldn't be there. We should have actually created this as a step, also this also as a step. So you see, just 1, 2, 3, 4. You'll realize once we are done with the complete modeling part. Right now, just proceed. Load level, and finally create extrusion, and that should go from 1, 2, 3. Oh, sorry. This and this. TR, and get rid of this lines, and 0 to 1 feet or 6 inches. I forgot. Yeah, that's better. No, it got flushed, so that was supposed to be 6 inches. And again, default, and the last one, and that would be load level, and this particular stage, so that would be just here itself. TR, and join this to this, and join this to this, and 0, and let's 1 foot, it's fine, and default. Apply. Okay, and finish. First, let's see it in 3D. And accidentally, I guess we happen to turn on this compound wall layer, the visibility. So SA, select all of them, and again hide in view by elements, so we can properly visualize the landscape elements. And I guess I created this at the wrong work plane. Yeah, so see, level plane. So edit type, and select all of this, edit work plane, and not this one. Oh yeah, okay, only this particular, this landscape elements, edit work plane, and send it to road level. Okay, and yeah, now we can have a proper visual appearance. That's okay. And you see that for this particular thing, we need to create a wall that will, which needs to hide this structure, otherwise the water will, no, what, that's okay, that is the next, we will do it later. Right now that's not important. Right now what important is that you need to have a closed shape over here, this particular, yeah, okay. So let's complete this shape, and let's continue with the garden part, and then we'll apply the material, finishing material to all of that. Extrusion, and just a simple extrusion. Again, the work plane, set work plane, and I don't want to mess road level. Okay, and a rectangle, and started from 0 and 4 feet 6 inches. Filling, and let's go to 3D. Where did it create? Yeah, it created properly. Not an issue. Fine. So the last part remaining for this landscape is that we need to create this garden part. Yeah, and also we will have one wall over here. So just like this, CO copy and copy at this end, extend it to okay. Oh, that's okay, not an issue. And last part is that this garden we need to create. Okay, so that would also be again a soil filling only. So let's go to road level, and first let's create an extrusion, pick lines, and that would be this boundary. Oh, sorry, delete, pick lines, pick this. There are a few overlappings. That might be the glitch with the AutoCAD plan. 2, 3, 4, 5, 6, 7, and yes, TR and finish. This 2, TR and finish. And 0 to, what do we say? This is only, let's say, 2 feet. 2 feet 6 inches, or 2 feet is also enough. Let's keep it 2 feet 6 inches. Yeah, so see, I told you here there is a problem. And let's just delete this and then pick lines. No, this is creating entire. Okay, 2 feet 6 inches, fine. And 3D, okay, and this garden. So for that, this particular plinth will be at 3 foot, but from here, wireframe, and let's see the AutoCAD plan. There is the AutoCAD plan. This is the AutoCAD plan, and this filling would be a little bit less than the plinth level, but right now let's not get into it. That the landscape designer can decide, and let's have it at 2 feet. One and 2, 3, and all of this again. TR and this finish, and finish, TR, and here I guess we have drawn a lot of lines, and just remove this line. Okay, and 0 to 2 feet, and should be grass. And AutoCAD already has the default material of grass, so you don't need to. Okay, and just finish it. And last one, create extrusion. Or actually, what we can do is just edit this extrusion and have a more close shape. TR and pick lines, and yeah, TR. Join this with this. Okay, so finish, and we have our landscape created. Now is the time to add the finishing material to this. So this particular thing, what we have created, entire thing, this would be the soil filling, okay, which we don't need to quantify. But now the layer, the finishing layer, the stone layer which we will provide onto this, that needs to be quantified. Okay, so that has to be created with the floor command. But right now, just to save the time, I'm not going to go into the detail of this. Should have 3 feet 6 inches. Okay, and right now, just to save the time, I'm just going to apply the material to this and not create the individual floors, because that will again take a lot of time, because you see that how much time did it took to extrude all this, because it out its weird profile. So right now I'm just going to give it a material which I have already defined. So this would be the stone, black stone, yeah, and that would stay same for all of this. 1 and 2, 3, 4, 5, and black stone. Okay, and this too. 1, 2, 3, 4, 5, and black stone. Okay, and this would be the amphi material. I have already defined it. Yeah, the appearance. Okay, and yes. Okay, but the texture is not proper for this material. Empty material, and let's just change it. Let's provide this, or let's provide this. Done. Apply. 5 feet by 5 feet is okay. Yeah, that's better. And this would be the same material which we have provided for the compound wall. So again, the compound wall material. Fine. And this is not getting differentiated, so let's change this material to empty material. Okay, yeah, so is anything left with the landscape part? Yeah, the only thing is that here also there will be one. So create extrusion, and that would just be a small sliver saying that it is zero and 1 inch, and apply it any existing material, but something different from that black stone, and that could be grass. Apply and okay, and finish. Ready? Where did it create? HH. Where did it create that material? 0 to 6 inch road level, and yeah, fine. Why is it not showing? Okay, so already there is a floor plate which is defined, I guess. Yeah, okay, already there was a floor plate, not floor plate but the extrusion. Okay, finally done. Okay, and what remaining is this particular walls that we need to add, which I said that we will add later, but let's just do it. We need to extend this particular wall up till this face, main wall 9 inch, and let's extend that particular wall up till this face. Okay, and let's see it in 3D, not 3D, sorry, road level, and whether did it extend properly to the particular level. Yeah, okay. And likewise we need to create one, two, yeah, couple of walls. So just select this wall, main wall, CS, that is create similar, and the constraint should be road level and up till plinth level, and just pick lines. And with that finish face exterior, just 1, 2, 3 and 4, and this has been placed properly, but this needs to be and till here. And this also needs to be flipped, and then this also needs to be flipped, and then this TR, and join it, and let's see it in 3D. Again, where did it create? Yeah, it's created a perfect place. You just need to hide this water body to visualize that wall. Okay, and let's change to CC because you cannot visualize it properly. And yeah, okay, if I just change this layer HH, fine, that's HR, and that has been created perfectly, so no issues. Even if I just hide this wall, then this particular wall can go up now from this point. Okay, and just like that, here too we have created that. Only thing that we need to join somewhere, and no, if then just join this. Yeah, okay, so likewise we also need to join this. And don't worry, the external layer of plaster will be wrapped and that will go up, but the geometry should be joined in order to properly perceive it. And you see that here also there is one wall which is left, and CS, and just pick lines, one over here, and join, and see how efficiently we can work in 3D itself working with Revit. And with this everything is done, and yeah, here too I guess. So CS, pick lines and pick this. Okay, join, and join this with this, and you see this external layer of plaster, that means that you can take this wall. Okay, so beautiful. Here also one remains. Oh my god. CS, pick lines, and 1, and till this point. Okay, and join with this. And now if you see in realistic, and everything is perfect. Okay, only thing is that this particular exposed site which you can see, that needs to be applied the material of mud, and that we will define here itself, edit in place, because that is also not going to be quantified. So just for the proper visual appearance, we need to create that thing, and road level and just a small sliver of 1 inch, it's fine. And just a rectangle, and from this point 1 2 3, and just select the edges, trim this width, take this all the way here, pick this line, pick and pick, okay, and TR and okay, and TR, and this should join with this, and just apply a material of grass also can do, but we do have an existing material, not existing, but I have already made one material of glass. Mud as well, one mud, and copy, appearance, duplicate, paste, select this image and look for that mud 43, yeah, fine, and it should be applied some bigger scale, 15 feet, done, apply, okay, and finish, TR, finish, and finish as well, and 3D, okay, let's look much better, okay, and we are done with the landscape part. Okay, complete landscape part, everything is perfect. The only thing is that now we need to start the main part, that is the modeling part. Also this stairs needs to be applied some material. Let's give it a material of black stone only. Stone, black stone, okay, fine. And let me just turn on this bulb, select this one wall, chain of walls, and hide in view by elements, and okay. So what remaining is for this particular, up to now what all we have created, there should be one beam over here. See, we forgot that, so let me just do the needful, go to the ceiling plan and ceiling plan of basement slab, and just zoom in, press tab until you find that structural framing, then snap it to this point, okay, and along with that beam wall, that too needs to be snapped, okay, and this particular needs to stop here, okay, on 3D, and yeah, we have added that particular wall which was supposed to be there, okay, fine. And yeah, also I need to add the layer of this PCC to all the other foundations, but that's not important. You can do it by the way I just showed it while starting this particular foundations. The modeling of this foundation, the first layer is that you need to add the layer of PCC, okay, and let's create the road and create the structure till this point. So let me just go to road level, and that too will be just a simple extrusion, edit in place, create extrusion, pick lines 1 2 3 4 5 and 6 and 1 inch, and just give it material of existing gray and we have the asphalt gray. We can apply that material, apply, okay, and finish. Yeah. And is anything left for this particular floor plan? And yes, actually this water body should have the material of ceramic tiles to give an exact look of that to the wet area. Okay, so let's just do that. Wherein this is the model in place and defined by extrusion and everything, and this is actually a floor plate which is actually not needed, so let's just delete it. And herein I will just go to edit and place, and I will just this hide and create a couple of extrusions. Let's just quickly do it. It will not take much time. And let me just go to road level and find create extrusion, and extrusion from here to this point and here till this point. Okay, and let's just delete this, split and TR and join this to this and this to this. And also we need one floor plate, I mean that material over here from this end to this end. And yes, after that 2 more extrusions, and we can just use this as a reference, edit extrusion, and just use this particular thing, CO, and finish this and create extrusion and just paste it and offset it 1 inch from all sides, interior side. Okay, and just finish and have a close shape. Okay, and this too. Fine, and that should go from 0 to 3 feet, or let's say 2 feet 6 inches. We can adjust it later. For right now, just okay. And just change this material from asphalt gray to, where is this, plinth flooring toilet. Yeah, so just duplicate this and call this water body and swimming pool, SP for short, tiles. And just copy it, and in the appearance duplicate that as well, paste it, and now it's not allowing to rename. That's fine, let's not waste time on that, and let's just select this one another. Okay, and let's just give it a tiling of 6 feet by 6 feet. Done, apply, okay, and just finish. Okay, so we will position it later, but first is that. Okay, let's just do that. Move it and move from this point to this point, and wrong point from here to this point, from here to here. Yeah, it's not snapping perfectly to the desired. Move from here to here. Yeah, okay, so fine. And this is the bottom plate, that's why I guess we need to join the geometries 1 and 2, and yeah, you will have one more. And likewise here too you need to create that, so create an extrusion and just snap it. Okay, and offset rectangle 1 inch or -1 inch, and just draw that rectangle. Yeah, and it will draw it for the interior, and 0 to 4 feet 6 inches with that water body and just copy, apply, just go to 3D, and that has not changed the material. And why is it still showing the asphalt gray? HH, and this material, oh yeah, paste. Okay, perfect. See, okay, HR, and that will turn on. And this is, where is the material, where is the, we deleted that, so we need to bring this and copy to clipboard and paste, align to selected levels, and place it at plinth ground floor. Okay, so that will make another copy of that. And then with that another copy, what you just need to do is apply the material of water, and that is how smartly you can work with Revit. Okay, so done. Fine. What remaining is that just to join this geometry in order to see one surface and have a better render appearance. And somehow I feel that this particular material should be mud and not grass. That's all. This is not important, but just I want to make it look perfect, so that's why I'm giving so much of inputs. HR, fine. And see, here there is a glitch, so just finish this and HH, and just take this particular wall. Let's go to road level and take this wall from this point to this point. Yeah, it's not joined. Yeah, okay, 3D. Okay, that's better. And likewise here there will be the load bearing wall, and here I see some glitch, so again just snap this to this point. And likewise here also there will be, yeah, see, snap this to this point. Okay, and with that HR, and I hope and I wish that nothing is left now for this particular plinth floor plan. So you see that for working almost 5 hours, we have only been able to complete up till this plinth level, and the superstructure is still yet to start. But that's okay. The detail which we provided and the level of detailing with which we completed this, that time was worth spending. Anyway, so now let's start with the superstructure. Okay, and for that purpose we are going to first construct this particular area. If I just take you to this road level plan, then here is that gazebo and gymnasium, and on the top of that there is a bedroom and home theater for this residential apartment, a typical floor. Okay, so this is just a G+1, G+2 structure, and this is that again. For which we are going to start off with this particular portion, which is actually a G+1 structure, that is the water body and gymnasium, and on the top floor it is a bedroom and a home theater. And what follows for this particular site is the typical floor residential apartment. Okay, low-rise residential apartment. So we will construct this particular floor, this particular part, this particular structure. And for that, what I'm going to do is that just select all of this and filter. And now the things are going to be a bit easy because the hardest part is done, and now we just have to take the elements and change its constraint and take it to the desired designated level. And structural columns, apply and OK, and that will select all the structural columns. But right now you cannot visualize that because they are part embedded in the architectural elements. So you see that base level varies. Of course, the columns on this side are going to the raft, whereas the columns on this side are going up to this particular combined footing or the isolated footing. So for the top, it says that the plinth ground floor, and I'll just change this to first floor. And with that, you see that all the columns have been elevated to that particular designated level. So as I said, the things are going to be easy now. Okay, so let's the columns which are going to be part of the wall, so we do not need to apply any material to that, but the columns which are going to stay exposed, we need to provide the finishing material, okay, from the level from which it is going to be exposed. So we are going to select this 1, 2, 3, and let's actually select 1 and SA. That will select all of these columns. And for that, I would say that edit type, no, these are the structural columns, so the finishing material can be provided from, so sorry, I forgot. So again, let's first go to manage and materials and create one custom material and create new material and call it duplicate, or let's rename it 1 expose, or let's say expose dot column finish material. Okay, and just copy it and under appearance say duplicate and just paste that. Okay, and change this visual appearance as to wall. Okay, and this time I'm going to select the existing material of Revit and not my custom material, and for that I'm going to go to appearance library and concrete, and yeah, to use this concrete polished, just replace it. And now actually I was supposed to duplicate, so we don't end up messing with the material of Revit. 20 feet by 20 feet, done, apply and OK. And then what we are going to do is architecture and not actually walls but columns, and column architectural, and you see that we have already this particular size defined, 2 feet 7 inches by 1 feet 1 inches, but that are for this bigger columns. So we actually need to go to road level and measure the size of that particular this column, and that I suppose is 2 feet 6 inches, but 9 inches is the width. Yeah, see. So what we need to do is that architecture and columns architecture, and just select the size and edit type and duplicate it, call it 10 inch, adding ½ inch of plaster on both sides, and be specific expose column, expose.c for short. Okay, and for this material part, just select that material we just defined, and herein just enter its depth only to 10 inch, apply and OK, and just let's try to, so that will perfectly be placed, but one element under the another element, so just cancel that. That is because we forgot to change the constraint, and that should go up till first floor, and then place it. So now if you just go to 3D, then you see that that particular column, architectural column, is wrapped with the structural column, and join and select that architectural structural column tab. Watch here, select tab and structure with architecture, so that will be perfectly wrapped. Okay, so we need to do it for that other columns. Just go to plinth level and select that, all of that. But one thing I would like to bring to your notice, that the floor height for this particular area is 11 feet. So let's just select all this structural columns SA and say that we're in, since it is a column, so we don't have an option to place the unconnected height, but we can give it a top offset of 1 feet. Okay, and select this rectangular column and that too top offset of 1 feet, so that will make its height 11 feet. Okay, and then let's just go to south, and this level I created by mistake, so let's just delete that, and again go to plinth, and then plinth or road doesn't make any difference. Select that rectangular column exposed that we just designed and snap to this point, end point, and this pink icon should pop up, and then place it, try to place it where it's not snapping to the point, doesn't matter. Select another point this side, and yes, 1. Okay, and then select this, again copy, and from this endpoint to this and this, and all the columns. It's not somehow snapping for this column, so we need to be careful while. Okay, and let's just go to 3D and see all the columns. Just join and structure with architecture, and tab structure with architecture. Watch this point, and tab structure with architecture, and structure with architecture. Fine. So we have all our columns placed with the offset of 1 feet, so that will give us a floor height of 11 feet for this particular area. Now next is, I guess this is not joined, so structure with we joined the wrong, and join and structure, tab structure with architecture. Okay, fine. So next is that we need to provide the piece of glass for this particular area, and let's go to plinth floor, and this is that particular glass. So we will just add a curtain wall, so architecture and wall, and let me just select the storefront and edit type and duplicate that and call it custom curtain wall. Okay, and let's have a spacing of 3 foot 6 inches and 3 foot 6 inches as well. And for the mullions, let's select this particular square, 1 inch square, and just copy and paste, and for all this we need to enter the same mullion. Okay, and with that just apply OK and pick lines, and let's just place one first. Okay, and let's place this as well, and this, but it snapped on the wrong face. Interior, we'll adjust it later, don't worry. Right now just place it, and now we need to adjust its position. Okay, and this should go from here till this point. Okay, no, but that is the layer of plaster, so the finished layer, so just try to snap it from outside. Yeah, and select this, and where it should be, its alignment should be at this face, so move from this point to this point, and then move it manually with 0.5 inch of dimension. Yeah, so that will perfectly be flushed because the glass and the mullion is 1 inch, so that's fine. Okay, and let's do that for all this. move from this point to this point and move it from here to here, and then manually move it 0.5 an inch, so that will give us a flush surface. And we need to change this, okay, and also this to hit this point, and move and select this part and then move 0.5 of an inch, okay. And this, just select this particular one and move it onto this face, and which is line, I guess that was the correct line, I guess. We cannot see the AutoCAD plan. Oh, the glass surface is here at this point, not this particular one. The glass is at here, so we will have to move it all the way from this point to this point, then move it 0.5 an inch, okay, and just PR and finish and have a close shape. But curtain walls joint condition at junctions is weird, and we need to provide the corner mullions in order to have the close 90-degree junction. This should actually go at this point, okay, fine. And this too, just get rid of the plaster and this here, okay. This should actually move to this location, move, and from this point to this face, okay. And likewise this too, move from this point, yeah, okay. And let me just see the AutoCAD plan, whether the glass on this face, which and road level, and isolate element, yeah, the glasses are perfect, yeah, no issues, HR, okay. And just let's select that particular curtain wall and go to edit type, and not the curtain wall but the mullions, and edit type, and for the material, just existing material of Revit sash, it will give a appearance of a wooden member, and just see it in 3D now, see, perfect, no issues. Only thing is that we need to give it a offset of finished floor level and enter, but that will, yeah, fine. So just do it for all the curtain walls, select one SA and just give it an offset of 75 mm. And you can have your customized grid and your customized division, but that would again take a long time. So right now let's try to change and have full. So let me just change this to 4 feet and vertical grid to 4 feet. And vertical is fine, 3 feet 6 inches is fine. Horizontal grid should be 4 feet. Apply. Yeah, see. So now we have a full glass on both the ends. Only thing is that we need to provide a door here, so just get rid of this mullion, press tab, press tab, and just delete this mullion, but it is pinned, so you need to unpin it and then delete. And for this particular grid, you need to say for that insert and load family and doors. Under doors, that is this library, English Imperial, and doors, you have this door curtain wall storefront, which we can reference here, and just select this and unpin it and change that to this door fine. Okay, and the only thing is that we need to give it material of, let's say, material copy. Don't forget to duplicate. Right now I'm just to save time, I'm just providing it a standard material, and this grid seems, yeah, okay, perfect, no issues. And now what next is that we need to pursue this particular wall, this particular area in section. Okay, this is done. So let's go to road level, and you see that here there is that particular wall which I was talking about, which I promised that I will show you that how to create this particular masterpiece in Revit, which will start, this wall will start from ground and will get converted into roof. So let me just draw one reference plane, RP. RP is a shortcut, and let's just say this section and flip it. Okay, and with that set and pick a plane and go to section 1. Yeah, and let's go to insert and import CAD, and I have already, yeah, this section, and you'll be provided with the AutoCAD file, don't worry. Change, okay, and let's just place it. Fine, it is placed but not visible. See, it is placed here, so we need to align, and again go to road level, and here is that particular wall, so modify and align, and just align this, and now position it properly. So the first thing is that align, and this level should align with this, and this face should align with this. Perfect. So you see we have a beam over here, and this is the cross section. So till particular this level, that is this floor height, that would be 11 feet, I guess. Yeah, 11 feet. So till 11 feet there will be regular walls, and then we will convert this particular entire wall with a different method, which is getting converted into the roof. But for that we will need to create this particular wall right from this point, and which will have a beam over here. Okay, so let's move step by step, and let's go to road level, and onto that road level I will say that architecture and wall, and this time I'm just going to select one, this simple generic 8-inch, and go to edit type and duplicate this and call it load bearing wall. Okay, and edit its structure, and 600 mm, that is 2 feet, it's a thickness, I know it, and let's provide it material of existing material of brick for now, or have I made that material? And if not, then let's just quickly make one new, create new material and rename, and one load bearing wall. Okay, and copy and appearance, duplicate that as well, and just paste it here, load bearing wall. Fine, and just load that custom mat desktop and custom mat materials, and from herein select this particular, I want to apply this material, this particular, let me just have a preview of it. Yeah, okay, yeah, let's provide this particular material, and open, and fine, tiling, for now let's get 4 feet by 4 feet, apply, and okay, apply, and okay. And let's create that wall. What would be the base constraint of that wall? Finished face exterior, and this would not have a core because it's a load bearing wall, so core is the main structure. So this will have the base constraint of road level, and let's see it in section. and not this particular section, but the one that we just loaded. So this is the road level, and from here it is having it to make it go up till this particular top of this step footing. We need to give it a top offset of -1 feet. This will be -1 feet. This will be 1 feet. I see this is 1 feet, and then from here in the top offset of from this particular level. No, yeah, fine. From this particular level, this will be 14 feet, including, sorry, from this particular level up till this, that is 14 feet, which is including the 3 feet of plinth. Okay, so road level and architecture and wall, and that load bearing wall. From road level, the base offset -1 feet and up to unconnected height, and that unconnected height would be 14 feet. Okay, and let's just pick this. Okay, and escape out and just flip the direction, and let's see. Yeah, okay, perfect, fine. So that has been created, but what left is that we need to create this particular beam. And in order to create the beam, what we need to do is that we need to select this structural framing, structural column, and for that, yeah, right, just isolate category. Okay, and why is this beam stopped here? Yeah, because here there is a water body, but just like this there will be one beam over here also. Just we can do that in 3D itself. Just take this, have a but that line will not be visible here in 3D. So for now, let me just drag this. We'll adjust it later, and modify and split. I don't know why that beam was deleted, might be deleted by mistake. And just create one dot here and TR and join this with this and join this with this. Perfect. So we have the beam going at that level, which will connect with that particular footing. Also HR, and again select this entire thing and filter and check none, and only the structural column, foundations and framing. Apply and OK, and isolate element. Okay, see, so you see this particular beam here is going at this level, and now that particular one wall, if I just turn on the category of wall also, but yeah, fine. HR one more time, sorry guys, and oops, sorry, and filter and check none and say that floors, structural columns and walls. Apply and OK, and isolate element. Yeah, so now we have to manually just hide the unwanted walls in order to visualize this particular thing properly. And actually let's hide this component. Okay, and see HH, and see this particular structure, this is going at this end, it is going perfect. Let me hide this floor. Okay, at this end it is going perfect, but here we need to join it. So let's go to top and join it at this point. Yeah, perfect. So we need to create one beam, one lateral beam, which will be joining these two beams. Okay, so for that we need to go to that particular beam will come at this level, that is plinth level. So we need to go into the plinth ground floor plan, and then structure and beam, and what is the cross section? Yeah, sorry, again I forgot. The size of that beam is 1 foot 7.5 and 1 foot 6 inch. The depth is proper 1 feet 7.5, but why to provide this width? So because that the width of that particular load bearing wall is 2 feet, and we need to leave the space for one brick to wrap. Okay, so 4.5 inch, that is one brick thick. For that much portion we will leave. So 1 foot 7.5 and 1 feet 6 inches. So again, go to print ground floor level, structure, beam and concrete rectangular beams, and just select this and edit type, duplicate it, call it 1 feet 8 inches, let's say 7.5 inches, cross 18 inches. Okay, and for breadth enter 1 feet 7.5 inch, and for height 1 feet 6 inches is fine. Apply, okay, and let's turn its justification to top in order to visualize what we are drafting, and that should go from this till this point. Okay, and I think the justification was supposed to be bottom, and this point and this point. Oh, top, actually top was perfect. Oh my god. From this point to this point. Okay, and I cannot select that particular beam, but on this I can select that, and concrete rectangular beam and isolate category. Okay, now what needs to be inferred is that from this end also we need to deduct 4.5 inch of thickness. But if I just take this and snap it to the center, then that will join. So what you need to do in that case is modify and say unjoin geometry. So yeah, so that will unjoin that geometry, and now with that you can just take it here and then snap to the center. Unjoin, and why is it not allowing to okay, and then and let's try once again and unjoin, and let's just take it here and then snap to the center. Okay, due to some reason it is not allowing to, but that's okay, that's fine. Okay, and let's just go to 3D, and yeah, see, so here is that particular beam, and this portion is not going to be seen, so that's okay. But from here what you will see is that this particular brick wall is having that 4.5 inch. Okay, so not an issue. And here also the space has been left for one brick, but due to some reason this particular conjunction is creating a problem, and let's just join and join this with this. Okay, so perfect, no issues. And now what important next is that we need to define the floor of this. And you might be wondering that sir didn't provide this particular beams on the top of this curtain wall. The only reason of that is if you just see this section properly, then on the top, the floor plate, on the top of the floor plate, this wall will go till, see again, this is needs to be 15 feet. Yeah, so on the top of that floor plate there are inverted beams provided. Okay, all this inverted beams. Okay, so let's first lay the floor plate and then we'll understand it. So to visualize this particular, to lay this particular floor plate, we need to create one level again. So LL, and that would just be 1 feet from that. Yeah, so LL, and from 1 feet from here I'll just drop another level and call it 3-1 first floor custom. Yes, pretty much long name I provided, and just take that all the way, snap, and yeah, take it all the way till this point. Okay, and now we have that particular label in our project browser. Yeah, see, 3-1 first floor custom, and it exactly positioned below the first floor. So this is the importance of following the numerics, sorry, not numerology, that's altogether a different thing. That was the reason of following this numerics. Okay, first floor custom, and we cannot see anything. That's okay. Just change this range level to first floor so that we can visualize this particular thing. And if I'm not wrong, then let me just go to road level and HR and see this AutoCAD plan. Isolate element. Okay, so this floor plate will actually come till this end. So if you just see it in this plan, then till this end I would say. And what is the width of this? 2610 and half. So road level, and let's measure this. 27.8. 27.8, and basically what is this part which it is showing? This is the wall. Yeah, so the wall was created exactly, yeah, see, the wall was supposed to be till this end, and because this parapet wall, yeah, okay, go it in 3D and HR. Yeah, see, this particular wall is creating a problem. Let's take this wall all the way till this point. Yeah, perfect. And then take this wall and join it here. And somehow it is joining, so unjoin geometry, and this layer is getting wrapped. So go to top and place it here till the extreme point. If you'll join, then that will wrap, but right now just stop it at this end. Okay, and let's go to first floor, and now if I measure this, then this should be 27, 10 and a half, 8 and a half. Still there is a problem of where did we create that particular wall? We create that particular wall on road level and plain ground floor, and yeah, so now it is perfect. So why is it showing that error? (27, 8 and a half). And what does that AutoCAD plan says? (27.8). Yeah, fine, no issues. Half inch of difference. That is the only that is always going to be the problem between CAD plans and Revit geometry, so not a problem. Okay, so let's create the floor plate and architecture and floor architecture, and let's select any of the plinth, ground floor, entrance deck, private, yeah, and just edit it and duplicate it, call it first floor custom, or first floor, let's say home theater side, or let's say custom, forget it. Okay, and go to edit type, and you see already it have all this finished floor layers defined, but in this case this will be a slab casted and will not be a layer of PCC. So 6" over here, and just change this to concrete cast in place gray, fine. And this layer of sand bedding will now be here in this case, and PCC or sand bedding, where is it, where are you? PCC and sand bedding, where is it? Yeah, okay. And that would have the, we'll manipulate it later, but right now just 20 mm. Okay, and that would make the floor thickness 9". That is too much, so we need to manipulate it, but we will do it later. But first let's create that particular floor. And boundary line from exterior point, this, sorry, not exterior, internal point of this to this, and just finish. Okay, and the height offset to 0, edit boundary, and then finish. Okay, and 3D. This is the floor created, and let me just hide this particular AutoCAD plan in this view. And why is this particular curtain wall? Okay, so again go to road level, and not road level, sorry, fence level, and you see that this curtain wall has by mistake, so let's bring it to the desired floor, and this should not be actually seen, but anyway, let's go to section. Okay, and if I just click this particular floor and go to edit type, and I guess I need to switch the units back to millimeters for, okay, edit type, edit, and yeah, so this brick beds and bedding, yeah, so this in this case should be 100 mm. Okay, and we are just considering the ideal situation that might vary according to the designer, but right now I'm just considering the ideal situation. And with that, if I just press OK, that makes the finished floor level of 100 plus 20, 120 and 151 of finished floor of level. Okay, so with that, let me just click this and height offset 151, fine, and that will take it perfect, no issues. And this curtain wall in that case will have a top offset of only wireframe, and this will not go till this end, but it will have the top offset of only 152. Yeah, so let me just select this curtain wall, and 152 is the top offset, so that will bring it in place. And likewise all this curtain walls, actually let me just press undo and select this curtain wall, and SA, that will select all the curtain walls, SA. Let's do that in 3D, and this curtain wall SA, that will select all of them, and the top offset only of 152. And now if you just see the interaction, then yeah, see, okay, perfect, no issues, and fine. Okay, so now before proceeding further, I just, and why is this door CC? Let me measure units UN and back to feet and fractional inches. Okay, and oh, that cannot be a door of 4 feet, so let's just change this back to curtain system panel glazed. Okay, and let's add a mullion here. So architecture and mullion and 1 square. Fine. Okay, and let's place the door over here, so that would make it visually look proper. 8 feet. Yeah, fine, no issues. And so let's delete this, unpin, delete, and unpin and delete, and just select this grid line and remove it, and then select this particular panel 3D, and let's see that panel in 3D. Okay, and yeah, panel, and it is pinned, so unpin that and change it to curtain wall double front. Okay, but that too seems unproportionate, but doesn't matter, we can manipulate this particular curtain wall here itself in 3D, and I'll just show you. Let me just change this back to system panel glazed, and what we will do is that we would get rid of this grid and this. Yeah, fine, and have bigger opening, and just delete that as well. Yeah, unpin and delete, and let's add a custom grid. Okay, so just go to grid and all except one pick, so approximately roughly 1 feet, because this is 3 foot 6 inches by 3 foot, so approximately the span is 6 foot, around 6 foot. So just let me pick and get rid of this. Okay, and likewise 1 feet from here, roughly 1 feet. Yeah, and delete overlapping grid lines. Yeah, fine. Okay, delete grid line. Okay, and all except one pick, and get rid of this. That will add to. Okay, and then just get rid of this mullion, unpin and unpin and delete, and add a customs 1 square over here. But this why did it add this particular? Delete and delete. Yeah, fine. And then after that, now unpin this glass panel and change it to okay, so that would look a bit proportionate. Okay, fine. Next, what is next? We need to add the beams over here. Okay, so that will be inverted beams onto this particular floor, but before that, let me just go to section 1, and this is that particular floor with height offset of this is the finished flooring UN, and let's change this to 151 millimeters. Okay, and that would be roughly around edit type and 100 plus 20 plus 12 plus 19, that is 151. Yeah, fine. So yeah, the height offset of 151 has been given. Okay, so yeah, everything is perfect now. So we just need to add beams onto this particular floor, that is the custom floor that we just defined, 3-1 first floor custom. Okay, so let's go to structure and beam, and concrete rectangular beam 9 cross 18 inch. Yeah, fine. Just justification to top. Let's see. Yeah, not top but bottom. Okay, and undo, and let's just place that one beam over here. Let's first place the peripheral beams so we'll understand. And 2, and from this point to this point, this one, yeah, this point to this point, and right. Okay, and here there will be a wall. You just see it in section, then this is that wall. So here we can provide the inverted beam as per this dimension. Not an issue, because anyways that is going to get flushed in the wall. But for this particular beams, for this particular one, this beam and this beam, again that will have a smaller size of that 151 mm, because that's need to be. And also this beams that we just placed, 1 and 2, let's go to 3D, and that should have a Z offset value of how much? This much. That should 6 inch, so minus 6 inch. Okay, yeah, fine. So by doing that we will achieve this particular beam to be perfectly from the, let's turn this to HL, and this is the bottom of the slab. Bottom of the slab from that particular top to top, that will be 1 feet 6 inches, 18 inches of beam. Okay, but these two beams, this and this will be of smaller size because they will be exposed. So 1 and 2. So structure, beam, again define different type. Do we have 9x12? Yeah, we have tie beams, we can provide that here. Okay, and that are actually going to act as a tie beam, so not an issue. And just justification to bottom, and from this point to this point, and from this point, why is it not? Why is it not snapping? Beam and okay, let's snap in the center. Okay, fine. And this justification should be right, and let's see it in section and wireframe. Okay, these two beams which are right now popping out of the finished floor levels, so 1 and 2 and 3 should be Z justification minus 6 inch to flush with the bottom of the slab that we casted. Okay, and why this then? Oh, that is, this is the tie beam, this is the tie beam, and this is the normal regular beam. Yeah, but that's fine, we don't need to, because that anyways is going to get embedded in the wall. Only this particular thing is going to be seen, so that's why. Okay, before moving further, this particular 6 columns which were given the constraint of first floor, now since we have already defined that particular level, so let's select, let me just select this and hide it until we can see that particular, and select this SA and hide that as well. And what we are doing is just changing the constraint of that particular 6 columns. So select that one column SA, that will select all the structural columns, and you see first floor and 1 feet of top offset, which now we have already defined that particular layer level, so that will not change its location, that will just change its constraint and properly define it. First floor and top offset of 0. Okay, and HR, and let's join the structural elements and join this particular floor with this beam, and likewise floor with this beam, and here too Fine. Okay, now next step is that we need to continue this particular slab and make it rest on this particular load bearing wall. So just see the section, then you see that the floor has been continued, and here there is one beam. Okay, and the size of that beam is 1 feet 3 inches by 18 inches. Okay, so let's just go to that particular first floor plan and select that particular floor plate, but we cannot see the AutoCAD plan, and again we need to go to section and just see that till what 1 feet 7.5, yeah, 1 feet 7.5. So we need to extend that till that portion. So just select this edit boundary and offset it 1 feet 7.5. Fine, and TR, and with that delete and just finish. Okay, and now we need to define one beam over here that would be 1 feet by 1 feet 3 inches, that is 15 inches by 18. Okay, so let's do that, and structure and beam, and that particular 1.7 and half, just duplicate it and call it 1.3, 1 feet 3 inches, and OK, and just change this to 1 feet 3 inches, apply and OK, and yeah, bottom, and just snap it to this point and create one beam from here till here. But it created wrong justification, so right. Okay, and with that now just extend this till the center and make it join. Fine, and just go to 3D. Okay, perfect, and this wall will go up, but that portion we have to design differently. Okay, fine. So now let's build the wall for this particular 1 and 2, and this here also. For that, let me just go to this particular AutoCAD plan, and from road level let's take it to the designated level, that is first floor custom. Okay, and let's go to, yeah, and by default imported categories, turn it to half tone, apply and OK. Okay, and we need to bring that floor plate onto here, so align line, and first draw the reference line and which point will be snap. So we'll snap this point and modify and align, and this face with this face. Okay, and I hope that the plan matches. And did we snap to wrong point? Undo, and which was that particular? Okay, LI, and yeah, this point, and align and make it okay. Yeah, so fine. Okay, so WF, that is the wireframe view of it. Since the AutoCAD plan is at exactly that level, and if we want, then we can move it to the finished floor, but that's it. We can see the profile, so not an issue. So now this 4 walls, this 1, 2, 3 and 4 walls, this will be again the special walls, because here there is a home theater. So if Revit also provides that special walls wherein you can create layers and have different functions within it. So if I just take you to the architecture wall, and you see that these are the different walls with that particular layer. So what we are going to do is that we are just, for now, we are just going to this main wall 9" and edit type, and this we are going to duplicate and call it home theater wall, or let's what do we call it, insulation wall. Okay, and edit structure, and this is the wall assembly that comes with Revit, which you can edit and provide the various layers. Okay, so herein I'm just going to turn this into the exterior-most layer, plywood shielding, and that is the material that comes with Revit. Okay, and half inch thickness, and then next layer on the interior side I'm going to provide is that down, and this is going to be the membrane layer. Membrane layer in Revit, if I just enter here 1" and press OK, and says that membrane layer function requires 0 thickness. So you cannot provide thickness to it. That means that what I inferred working with this Revit walls is that this particular membrane layer is provided for damp proofing, and it's always provided this material of damp proofing. That means that to prevent the outside moisture penetrating into the building, this thin streak layer of membrane is provided. Okay, and you cannot provide any thickness to it because it is almost negligible. That are as per international standards. I'm just explaining you the concept and the fundamentals. I might be wrong, I might be correct, partially correct, but what the point is that I just want to make you understand the concept. And herein I am going to insert 2 layers, and the first layer would be of a typical insulation layer, 2" heat insulation, heat and cold insulation, and Revit provides these 2 materials, that is exterior insulation and rigid insulation. Both are one and the same. Just say yes. Okay, and this next layer would be insulation only, but that insulation would be for polyisocyanate, that would be for acoustical treatment. Okay, and that I am going to provide a thickness of 3" which would have the studs at various distance. Okay, and this again going to be finished 1/4, and on the topmost, the finishing layer, I am going to provide this gypsum wallboard. Okay, gypsum wallboard, and okay, and that would be only 0.5 of an inch. So that makes a total thickness of the wall 1 feet 3 inches, that is 15 inches. Okay, and if you just press OK and apply and OK, and with that core face exterior or interior selected, if I just snap to this point and start drafting, okay, core face interior, and snap to this point and start drafting, then this is how this particular wall will be drawn. Okay, and right now I am not giving it any constraint, and let me just draw from this point to this point. Fine. Okay, now let's go to 3D. Okay, so this is that particular wall which has been created with all that layers in it. Okay, now let me just take you to this first floor plan, and let me just draw this horizontal section, and just let's go to this section and let's try to understand. Fine. So what you notice here, you cannot see right now anything because the detail level is, for course, we need to change it to fine, and now you can visualize this thing. So you see, we actually need this particular layer. If you just see it in 3D, then this particular layer should come till the end of this floor in order to hide that particular floor. Okay, because onto floor we cannot apply the finishing material of plaster or anything, so we have to hide that in geometry. But first, the composition of this. So this will work like, first we need to join this particular finished flooring layer with this beam, the join condition of this. So what I will do is this, I will just press HH, and what you see right now, that is this flooring is going up till this end. So it is joined, but you need to switch the order, and this is the way exactly it will appear, that this will be the floor plate and the beam will be casted, and on top of that you'll have all this finished floor layers. Okay, now HR. Now this wall is also going till this particular end, but what will happen is that this exterior layers, that is the insulation, sound insulation and acoustical layers, will stop at this particular end. So again we need to join that also. So join and join that. Okay, join first with this concrete, the structural elements, and then join it with this floor. Okay, you can switch order and make it appear whatever you want. You can also have this yeah, okay, fine. The floor will be casted, and yeah, fine, this will be the finishing layers, and this finishing layers wouldn't be seen here, but here at least it will be seen. Okay, fine. And now if you just see it in 3D, then it doesn't make any difference, and this small glitch pertains to the join condition, so nothing to worry. If I just go to this floor and take this wall to the outmost part and just see 3D, yeah, see, so it is actually, we're snapping to wrong line, so that's why. Okay, but if you just see it in this section, then it is perfect, no issues, fine. And I guess here there is switch order, and yeah, and let's see it in 3D, yeah, fine, no issues, now it is perfect. Okay, so likewise just create the walls for all the peripheral walls, and showing a lot of things right now. I might, yeah, so range level just turn to none, only until we can see that particular floor plan. And yeah, okay, if I even turn off this AutoCAD plan, then it will be much better, and this needs to stop here. It's not exactly snapping to the point, yeah, but that is just a beam, so it will go to the center part. That is because the wireframe, oh yeah, fine, sorry, that was just because the wireframe view of that has been, this will also go to the center. Okay, and now let's construct this 4 walls, and just press this wall and CS, and with CF selected and location line core face interior, just snap to HR and wireframe, yeah, this point, and press space, just draw this wall from here till this point, and from here till this point. Okay, and from here till this point, and just TR and finish this TR, and that is already okay, fine. And just see it in section, and this side also you need to join, and here we don't have any beam, so not an issue. This will be flower bed, switch order, but it's not joined yet, yeah, okay, and perfect. And this particular section needs to be taken to this end in order to visualize the joint condition for these 2 walls, and this is the joint condition HL, and fine. So join and join this core structure with that wall first, and then this with this. Oh, perfect. Likewise, this will also, this is the beam. Let me just turn on thin lines. This line, actually there is some glitch, and then switch order. Yeah, perfect. So you need to just play around with this a little bit, try a couple of options, and then you'll be able to get it perfect. And again, join with this core structure with this, and join and switch order this with this. No, sorry. And let me press undo and join first this, and then join the structure with, or it's actually joined, I guess. Switch order. No, it's not joined. You see the hatch overlaps, so still we need to join it. And then once you join it, switch order. And yeah, but that is again a wrong join condition. Let me press undo, and let me just hide this wall for now. And first let's join this with this, and join and switch order. Yeah, and HR, and join this with this. Okay, and also join this wall with this, and perfect, absolutely perfect. Now no issues. See, fine. So this would be the join condition. Oh, where is the beam gone? Oh my god. Join and unjoin geometry. Okay, and let's first HH and join this beam with this floor, and switch order. Yeah, and then HR. Okay, and join this beam with this wall. Yeah, fine. And join this wall with this flooring. Okay, and finally, not last but least, and join, switch order. Yeah. Okay, so this is the formation of this particular four walls, these four acoustical walls. Only thing is that select this and press tab. You can select the chain of walls, and you need to give it a depth of -6 inches in order to hide this particular floor, which is the structural element, and you cannot apply the layer of plaster to that. So just give it a base offset of -6 inch, and that would do the needful. Fine, and perfectly pursued these four walls. Fine, now let's continue with this, constructing these two walls, which are the regular wall, and then this wall. So first is that let me press HR, and this walls needs to one, and press tab. So it will select all this wall, and unconnected height to 9 feet for now. Press all the chain of walls. Press tab, select all the four walls and 9 feet. Okay, then we'll manually join it once we create this particular roof. Okay, so let's go to first floor and draw this regular walls, this one, and herein there is no wall, but this is just a glass, piece of glass, but there will be a beam at least, but beam would not be at that level, so just a piece of glass, and the wall only over this space. Okay, and the beams on the top of these two walls will be laid in a different manner when we actually pursue this particular curve wall that I'll show you. Okay, anyways, right now just let's construct this wall and then this wall. So let's go to third floor and wall, and just our simple wall, main wall, and that should go from first floor and unconnected height. Right now let's just give it 9 foot because we have to align that particular wall with the shape of that roof. So press tab and from here to here, and here we have 4.5-inch wall, but that's okay. Select this, edit type, duplicate, and call it internal wall 4.5 inch, and edit type, and you don't need to do anything, just convert this to 4.5. Okay, apply and okay, and just select this wall and also change it to the 4.5 internal wall. Where is it? Yeah, that will do the job. Okay, now next thing is to conceive this particular wall, but before that let me just add wall and the curtain wall, same curtain wall that we just drew down, custom curtain wall, and this time again it is going to be first floor and unconnected height 9 feet. Just pick lines and pick this. Okay, and just move it to this. Okay, actually there will be a window here, but since there is no wall, so you cannot host a window. But since this is a full so let's create that curtain wall only. No, I don't want this curtain wall, and go to first floor and wall 4.5 inch internal wall. Just pick lines, create one, and just move it to this point, and we will add the opening later. First let's conceive this particular shape. Okay, so now is the main part, the main highlight of this particular tutorial, wherein we are going to construct that particular roof. But we cannot see it in this section, and only reason being this section is plinth floor, and yeah. So PK, that is pick a plane and pick this particular plane and go to section 1. So whatever you make will extrude from that point. Okay, and CC. Fine. So we are now to construct this shape, wherein this much part will be the wall and this will be the roof. Okay, so let's do that. And first we are going to, this particular wall is, and the roof is not possible by the conventional wall, so we are going to use add component, model in place, and wall, and call it wall 1 and load bearing curve wall. Okay, and just change it to WF wireframe, and then just pick extrusion, pick lines, and till this point it will be conceived as a wall till this particular point. TR and TR, and pick lines, TR and T, join it, and okay. Right now just finish and give it the same material, that load bearing wall. Where is it? Load bearing wall. Yeah, here it is. Okay, and okay, and just finish. Fine, and now let's just see it in 3D. Yeah, perfect. You will see this curvature lines, but I will show you how to get rid of that later. Right now let's just finish the modeling part, and this will not be seen, so let's just finish this first. And for this, let's say that join switch order and pick this join and switch order and this and this and okay, and join it, yeah, and then join it this with this and then join switch order, and it should work hopefully. Perfect. Didn't work. Anyways, we'll work it out that later. Right now let's concentrate on the modeling part, and this point should on the plinth level floor plan. This should go from here till all the way to this point. Okay, and what is this? Let's snap it to this point. No, that was correct actually. And yeah, and this point should go till here. Okay, section 1 again and CC. Okay, now what we are going to do is that we are going to conceive this part with the same method, but the only thing is that we are going to model this part not as wall but as a roof. So component model in place, and this time I will select roof. Okay, so that will schedule and quantify it as a roof, and okay, and call it load bearing wall roof, or let's say that curve roof. Why so much long name? Again, give extrusion, and now we have to pick lines and do that a couple of times. So HL, and first make this particular part 1 2 3 4 5 6 and 7, and likewise just stay tuned and all of that. Okay, and TR and just finish it. TR and just finish this and have a close shape, and this is going to be also the same. One, and where are the custom materials? Yeah, so load bearing wall and okay, and finish. Lines cannot intersect each other. TR and finish. Delete. Oh yeah, so it's creating a problem here. Just delete this line, and you need to have your AutoCAD plan absolutely perfect for this, and only this and TR and join this to this. Okay, and then finish. Hopefully it works. Lines must be in closed loop. And TR, continue, and TR and join this to this. Okay, fine. And then this slab, now we are going to define the slab into this, which will have this inverted beams. So what we will do is that create an extrusion again, and before creating that, let me just select this and edit extrusion, and let me just copy this profile, Control C and finish, and create extrusion and Control V, and just use this particular inner face, so we don't have to draft it again, we don't have to pick lines again. Okay, and just click this and move to this part. Okay, and then pick lines and the inner edge of it, outer edge, sorry, not inner edge, this all will be the concrete beams, a concrete slab and inverted beams. And TR and join this geometry and join this geometry as well. Okay, and just before escaping out, let's just copy this profile again, because we need to do the layer of that. But this time this material will be conceived as RCC, or let's say that concrete. And let me select this concrete cast in place gray. Yeah, fine, that's okay. And finish. And the last extrusion, create extrusion, and again Control V and just delete the inner segment and the delete and select this and move to this point from here and pick lines, pick all this exterior line and finish, and TR and join this with this, and have a close shape, this to this and this to this. Okay, fine. And what would be the material for this? So this is the layer of this will be the layer of waterproofing on terrace, which we need to provide. So just give it the material of brick beds and that would be enough, because anyway that portion is not going to be seen. Concrete and brick beds, 1 brick beds, yeah, okay. And just the cut pattern is important, and fine. And last one this, so again Control V and delete all of this. What we need is just this curve shape and that to the exterior of it. Oh, sorry. First we need to create and say extrusion. Sorry. Control V, and yes, now just delete this entire part and just have this outer segment and move it to this point. See, it's not snapping to. Okay, move and endpoint to endpoint, yeah, and just finish this. And yeah, and pick lines again, and all of this we have conceived as a part of roof in order to schedule and quantify, and in order to add the skylight. We cannot add skylight to walls, we can add only or add skylight to roof, and that's why this portion has been conceived as roof apart from its scheduling and quantifying part. And just finish, yeah, and finish. Okay, now let's just go to the, but we'll not be able to see anything, so we need to go to the floor above that. second floor. And yeah, so see all these elements we can see, and then just snap that point to this layer WF, and HH, and you cannot don't have the drag handles. We have it here, fine. So snap it to this, and this snap it to here, and this snap it to this point. Okay, and let's just go to 3D and see. Oh, fine. That shape has been pursued by us. Not exactly mimicked, but this would be enough. And only thing what you see is this particular different layers, and there is no way to treat it because they have been modeled with this modeling place and this 3D extrusion command, so we cannot add the external layers. But what we can do is that just modify, and you have this option paint, and what we can do is just paint, and we can apply the similar material and this load bearing wall and apply that to the faces, and pick, fine, and same here, pick, and also on the top, and 1 and 2, all these faces. Okay, oh sorry, undo, and yeah, so we'll be able to pursue one homogeneous surface. Okay, and finish. And then what we need to do is that finish this shape first, and then just, I told you that in order to get rid of this line there is a way out, and the way out is that while going to this particular different line styles, under that you have this invisible lines, and just click and just get rid of that line in order to see one homogeneous surface. And in section 2, and yes, this is invisible lines, and yeah, okay, yeah, just time consuming, but in order to achieve what we are exactly looking for, we need to do this. Fine, and on this here as well, and the top segment also, I don't need to see any lines. Okay, also get rid of, no, but then we'll have to do the entire this particular thing. So actually only the inner lines were supposed to be the one showing their profiles. Just undo and get all the lines back. Okay, yeah, fine, this is better. And yeah, only this lines, invisible lines, and only the inner lines we need to get rid of, and the peripheral lines should exist showing its profile. Okay, and likewise on this side as well, and paint and apply that, paint and apply that load bearing wall, and just select the surface, paint, load bearing wall, and Why cannot I? Why I unpick the face? Oh, we need to be in that edit. We need to be in that mode. And now just paint, apply this load bearing wall with this entire face, this face, and this face, and then done and finish. Line work, invisible lines, and only get rid of the internal lines, but anyway they are not seen. Oh wow, okay, so not an issue. Okay, what next is that just select this AutoCAD plan and hide it for now. Also this and hide it. Okay, you can properly visualize the structure. Now what we need to do is that select this particular tab and all these walls and attach top base and attach. Okay, but it didn't wrap in this case, but it didn't wrap in this case. And why is that so? Yeah, okay, so the extrusion was started. If you just if I just take you to this particular first floor plan, and you see that this particular reference line was set as a work plane, but the layer of plaster, that particular this layer is 0.5 inch. So what we need to do is that edit in place and just add that 0.5 thickness to all the extrusions. Then you'll be able to snap this external layer of plaster till that roof, and minus 0.5 inch. Okay, and then just finish it. Select this wall, detach top base, and again select that wall and attach top base, and wow, okay, perfect. Likewise, you also need to select this chain of walls, tab, and select this wall and select this wall as well and attach top base. Okay, only thing that you need to edit its profile here in section, but before that I guess that here also there will be one wall, which I forgot to. Yeah, if I don't draw a wall, then will not be able to add a door to it. So architecture and CS, create similar, and from this point press space and to this point. Okay, and 3D and select this wall, attach top base and select this wall. Fine. Only thing is that you need to edit this particular profile. Revit removes top and base attachment prior to editing the profile of the wall. Okay, fine. And just try to pick these lines. And I need to go to section 1 for that. Yeah, fine. And it should start from, it should actually follow this shape, and TR and finish. Lines cannot intersect. Yeah, fine. Finish. Can't keep. Yeah, and join. So the trick here will be, again, we need to drag it all the way up and then edit its profile. So edit type, and then you will be able to snap to the lines of that shape, and TR and join this with this and get rid of this and finish. Yeah, perfect. Okay, and likewise, yeah, this wall too. So just detach top base, detach, and just take this little bit high, and then edit profile and go to left view, and now we'll work in 3D only. HL, no, not HL. Yeah, let's check CC. Let's turn it to CC. Consistent colors. We can 1 and 2. And yes, yes, and yes. Okay, and just trim, just get rid of this line and TR and finish this, and get rid of this line and finish. Okay, and R, enter. Realistic, fine. Okay, what we need to do next is that we need to apply this. We need to do something about this, and here too there is some problem, some small glitch. This point should come to here, and top view. And just try to snap it perfect, and then visualize. Again, this is joint condition only, doesn't matter, and we can overcome that just by saying that join and switch order, and select this particular beam and this beam. Yeah, fine. So that's done. And also this particular thing is not yet the part of this, and this particular junction will remain like this only, because it's not done by normal wall command, so we cannot have the layer, wrapping layer with that geometries join. See, the concept is that if I just join this, okay, then that will join perfectly. But if I want this particular layer to appear on the top, on the outer surface, and if I just say that switch order, and I'll select this particular beam and this wall and this particular wall, and no, sorry, join and switch order, and join and CCR, enter, and again switch order and select this and this. Then what it does, that it will give it a desired look, but in that case what will happen is that if you just select this, then you see that the beam has been deleted. There is no beam anyway right now here. Just take it to section, and you see that beam, first floor, and let me just take the section, and see the beam has disappeared. Okay, so the trick in this case would be only that just let it be, and let the exposed structure look like at this junction. Okay, so let it be just set like this, and also still the beam has been discarded. So now if I say that, you see the beam is going. Okay, fine. And if you want to hide this, then just give it an extrusion 0.5 inches more than the surface of this beam, but I would rather like to watch it in this manner. Okay, and all this element in its original state. Since we have exposed brick here, and we have this, and we have a wooden look here, then why not let this beam be in its original state? Fine. And this side, oh my god, HH and HH this wall first, and first we need to connect the structural elements which are not joined, and this to this. The floor plate is not joined, so let me just select this HH and join and select this floor plate and this beam. Okay, fine. So now they are joined, and HR and join that particular this inverted beam with this wall, and also HH and join this beam with, I guess there is some problem with this beam. CCR enter, and let's go to section 1, and yeah, see, there it is. This particular one beam which we gave a different size, after placing it we were supposed to flush it till the bottom, and the Z justification should be -6 inches. Yeah, that was not flushed, so it was behaving like that. Okay, and if I just press HH now, and yeah, so join this beam, HH this wall, and HH this AutoCAD plan as well, this AutoCAD plan as well, and yeah, so see, now it is perfectly joined, and this layer of one brick which I said is wrapping. Okay, so HR, and just in 3D just turn this. We don't need this particular AutoCAD plan to be seen in 3D, so just hide in view by elements because it's very annoying. Also select this AutoCAD plan and hide in view by elements. Okay, and fine. So in this case, let the structure be visible like this. Only thing is that we need to give this wall an offset of -6 inch, but that will make it lose connection. Yeah, see. Okay, so doesn't matter. Edit profile, and again go to this elevation and HL, and just move it to this point, and TR, and delete and pick lines, and draw that profile again. TR and join this and finish. Hope it works. R enter. Yeah, fine. And let the structure be visible. Doesn't matter. Okay. So that looks better. Only thing that we need a flower bed over here, and that would be very easy. Not an issue. And yeah, also we need the window over here. So let's go to the floor plan of this custom and HL hidden. Yeah, fine. And architecture and a simple floor plate, we already have that, I guess. Flower bed, and yeah, just yeah, and just give it an offset of 2 inch. Okay, what happened? Then allow. Yes. Oh yeah, the finished flooring is also so 1 feet at least. Finished floor level is 6 inches. Yeah, fine. And 1 feet 3 inches. That will appear proper. CCR enter. And what is the problem? No, that has gone much above, so only 1 feet is fine. Okay, the only thing is that and that's the small glitch. Okay, and first floor custom again, and this here there should be a window, and I don't like this windows. Let me select, no, this is not that one, and windows, and onto that we have a lot of windows, predefined windows of Revit. Onto this awning, I don't want. Yeah, let's try this. No. Okay. Placement triple awning. No. Where are the sliding windows? Yeah, sliding double. Okay. This would do the job. And yes, and just place it for now, and let me just measure this 1, 2, and 13 feet. So let's duplicate that and duplicate and call it 12 feet. Let's have only wall of 1 feet on either end, and width should be 12 feet, and height is only 2 feet. I want it at least 8 feet. Not 8 feet, 6 feet. Apply and OK, and default sill height of 15 inch is enough. OK, and position it in the center. And it's 3D. Okay. Give it a sill height of 2 feet. 19 inch. Yeah, and the height of at least 10 feet according to the yeah, huge window. Let's make it 8 feet. Okay, that looks better. Perfect. Okay, and here we need to add a skylight, and also in floor plan, let's first add the skylight, and insert and load family, and square skylight pyramid open. Okay, architecture and window, and you cannot see, this was the reason of extruding this part as a roof, because you cannot add it to walls, you can only add it to roof. And just press space, or let's just where did it go, window, and cancel. Okay, and press space and position it somewhere over here. Oh, CS and press space, CS, and somewhere over here. Yes, and just delete this and flip the direction by pressing space, and give it whatever height or width you want. I want this to be 5 feet across, 5 feet. Apply and OK. Oh, bigger window. Fine. So that's the way you add skylight to this particular roof. Fine. Okay, and the last part is, and now we have to add a door to this particular 2 walls. Okay, so let me just click door, and we only have the single flush door. Let me load families, and same path, that is libraries, English, Imperial, and under that go to doors. Okay, and under the door, residential, and just select this. This is good. and open and let's use this 3-foot size for that. Okay, so we can host it here, there's no problem, but here there is no space. So what we will do is that we will just host it and we'll just take this a little bit inside. Doesn't matter, even if it doesn't comply with the AutoCAD plan, that's fine. And just move this point to this and give it a house sill height, or not sill height, sill height of 6 inch. That is finished loading, and you'll be able to see the full swing. And same over here. Okay, 6 inch, fine. And now let's go to 3D and see that door has been added, the 2 doors has been added. Okay, and why is this thing creating a problem now? This has somehow lost its profile. So what we need to do is that again go to this first floor plan and just see the section of this, and yeah, see, so edit profile, and let me just delete this entire thing and just pick lines again from this point. Let's just delete that entire thing and pick lines with this 1, 2, 3, 4 and 5 and 6, 7, and TR, join it with this, and this should join here. No, there should be a line. There should be a line in this case, and that should join here. Delete, and do we have something remaining over here? Yeah, pick lines, and 1 and 2. Okay, and just finish. And now let's go to 3D and see. Okay, yeah, perfect, fine. So this particular skylight is bothering me. Let's delete it, it's not a good skylight. And window and load family, and just go to that English Imperial and windows and curtain wall, and let me just skylight pivot hung. Yeah, that's fine. Open and just select the skies and load this. Yeah, that's better. That's better skylight, that will flash. And while going to edit type, you duplicate it. Right now I'm not duplicating, and give it a bigger size of 8 feet and 6 feet, and apply and okay. Or in fact, instead what you can do is provide multiple skylights. So CS and create similar, and 1, 2 and 3. Just check the alignment and let me just move it and position it properly. Accuracy is not right now important. Function, I'm just trying to make you understand. Okay, now what next is we just need to have a cross check of the join condition, that is the join condition of the structural elements to the architectural elements, and the join condition of a column to beam and beam to floor, and all of that structural elements to the wall, that is the architectural elements, at all the junctions, and rectify wherever needed. Okay, so we will start that, and we will start that doing with section and dropping the horizontal and vertical sections at various places. And we cannot visualize where the columns are right now, so let's just open this first floor plan, and this are the points where the columns are. These are the junctions and the beam and the column grid. So just keep this in mind. Okay, and let's go to, here is that particular section. So let's first just take this section to this point. Okay, that is the wall, cutting from the wall and column itself. So I will just take this section, and if you just closely watch, first is that we need to deduct this particular columns from this floor plate, this base plate which we provided. So join, and that wouldn't be much difficult, and that's very easy. And from this floor plate to this entire wall, and why is it not? Yeah, okay. Next is that we need to join the whatever geometry we did join, we need to switch order. That means that column should penetrate through that. Okay, and why is this creating a problem? Join and switch order. Yeah, perfect. Okay, so that much part of the floor plate has been, base plate has been eradicated. Next is moving to this part wherein we have a beam, we have a column going through and a wall also. So that is overlapping. We need to join this overlapping volume. So join, and very carefully watch here. Just select that particular main wall and then the concrete column. Fine. And likewise join this as well. That is the column with the beam. The column should also join with the beam, and likewise this particular column should also join with the floor. Okay, and let me just turn on this visibility graphics, thin lines, sorry, and join this particular thing with the but that is the concrete columns should join. But that is fine. Okay, this is absolutely perfect. There is no issues. We just need to join this with this. Yeah, fine. And join, and only this external layer of plaster should be joined. Yeah, and then join and switch order. Okay, absolutely perfect. So now can you visualize this? Okay, let me turn off the line weight, and you see this is in that particular part there is a column and also there is a wall, but only this layer of plaster is getting wrapped. Okay, as far as this thing is concerned, we have a column and the floor, this is coming up till this edge. So I think that this will go through concrete, and this, yeah, there is join, but we just need to switch order in this case because this is the column. So select, and this, yeah, but that has made it we need to be very careful, and join and switch order, and select this column and then select this floor plate, but then it is making this void. It is joined, but okay, join, switch order. No, as far as the column is concerned, this column will go through this. Join and switch order. Switch order and join and switch order. Yeah, see. My god. So finally we have achieved that, and the same join condition should follow for all the junctions. Okay, so we will quickly do that. Just stay tuned and try to follow. So join, and join this with this beam, and join this with this, join, and this should join with this. switch order. Yeah, exactly. So see, only this layer of plaster is getting wrapped. Perfect. And now next is join, and join this column with floor plate, and find everything is done. Okay, and likewise here too, join this wall with this concrete beam, and that beam is not coming up till this particular base plate, so that's fine. And then join this with this, and let me turn on the line gate. Yeah, join and switch order, and this should actually, this is not yet joined. Okay, perfect. And likewise this junction is done. Okay, fine. And now this particular join, and join this main wall with the concrete column. Yeah, fine. Likewise this column with, yeah, absolutely perfect, no issues. And this should join to this, and only thing is that join and switch order, and this column should go through, and no, undo. And yeah, this is the same glitch that we had earlier, so we need to try it a couple of options. Join and switch order, and select that particular, no. Okay, let me press undo, and again join geometry, and join this column rectangular notch, this structural column with this to this. Okay, and this column should go through, so this and this. Okay, join and switch order, so that is again join and switch order, this with this. Yeah. So see, we need to be very particular about what we are joining with what, and this is the exact join condition here. Yeah, see, again here there is a glitch, and this particular plaster layer should stop here, and join and switch order. Yeah, see, now it is absolutely perfect. Also this beam needs to join with this structure, and yeah, see. Okay, and this is correct. Okay, now this junction was difficult since it was having columns also. Now if I just take you to this road level, and if I just take this a bit inside and see, then that, yeah, that is a portion that we just resolved, so that is not an issue. Road level, and let me just take it a little bit further, and this junction, yeah. So again join, and join the main wall with this beam, and this to this, this to this. Okay, and fine, and this to this, and likewise this to this, the wall with this column, yeah, and this wall with this floor plate. So only this. In this case, let me just first get rid of this, and you see this external layer of plaster, this should go up till this end in order to hide the structure, in order to hide the finished floor level. Yeah, fine. And at both the places, at this also, at this place also, it should go up. Okay, the only reason being doing all this is that will help us scheduling and quantifying in the perfect way. Okay, so That's okay. Now we have already rectified this, so this is not a problem. We have already made this perfect from first only initially doing it only. This is the problem. So join this and this wall. Yeah, so okay, the finished floor levels are going to this end. And undo, redo. Where I was, yeah. So what is the problem here? Why is it not? Is there a beam here? Yeah, a concrete beam. So join and switch order and this to this. Okay, but again unjoin geometry, this to this, and then join it again. This entire beam with this wall and beam with the floor, and somehow this order has been switched. Undo and switch order and this. Okay, perfect. So beam is joining with the slab and this with this. Okay, this and this. The tenfold of this, you are going to face problems while doing this, but don't worry, just follow this video and try to understand the basics and fundamentals and you will get it through. Don't worry. Switch order and this to this concrete beam. Undo and let's hide this particular wall, and this is joined already. Only thing that we need to switch the order. Yeah, perfect. And HR, and only thing is that join this wall with this. Okay, absolutely perfect, no issues. So you see, this is the perfect join condition and the hierarchy of how the architectural elements join with the structural elements and the layers join with one another and the join condition. Okay, but you see that it is taking a lot of time, so it is not possible for me to do that for each and every junction, but this was I wanted to show you that how to have a perfect join condition. Okay, and so far as far as this particular structure is concerned, we are done with this completely, and now we have to move to the next part, that is modeling of this particular residential apartment, which is a typical story structure. Okay, so let's start.